Okay, this is all the physics course revision. We have page 13 to 21, page 13 to 43, and then 53 to 65. No, actually to 69. So we have a good 40 pages. Let's start. What's the difference between scalar and vector quantities? Obviously, scalar quantities only have a magnitude, and vector quantities have a magnitude and a direction. Give two examples. Scalar would be distance and speed. Vector would be displacement and velocity. Pretty easy. Okay, in a coordinate system, plot the points A minus 2, 0, B 0, 3 as measured from O. Point C is 2 units above A and 4 to the right of B. Okay, questions like this I don't think will come, but like we're still gonna solve them. Where's my open board? So they just want, I'm just gonna open the solution. Okay, so you're just gonna go, okay, point A at minus 2, 0, like they said, minus 2, 0. Okay, and B 0, 3, so you just go 0, 3 units up. Okay, I doubt they're gonna get this. Okay, and then they said for part B, what did they say? As measured from O, from the origin, point C is 2 units above A and 4 units to the right of B. Okay, so 2 units above A, you see 2 units above A. Okay, so it's at this height, and they said 4 units to the right of B. So from B at this same height, we go 4 units. So this will be over here at 4, comma 3. Okay, wait, what? 2 units above? 2 units above A. Okay, this is wrong. 100% is wrong. It's 2 units above A. فيعني it should be over here at this height. This is 3 units above A. This is wrong. It should be over here where I wrote. Okay, I doubt this will come anyways. Okay, taking the Earth's orbit. Okay, this will come. Okay, they get, instead of this, they say a horse. I remember the question. A horse ran a semicircle. I remember that's how they got it. Taking the Earth's orbit to be a circle of radius 1.5 times 10 to the 8. Determine the displacement and the distance in half a year and 1 year. Okay, let's start with half a year. Okay, we're gonna draw the track of the Earth. It's like this. Okay, we know that the radius is 1.5 times 10 to the power of 8, right? 1.5 times 10 to the power of 8. Okay, let's say we started here at point A and we ended here at point B, right? It's half a circle. What's the displacement? The displacement obviously would be the shortest path, and the shortest path in this case from A to B would obviously be the diameter, right? And how do you find the diameter? You just multiply the radius by 2, and you're gonna get 3 times 10 to the power of 8 if I'm not wrong. Is it 3 times 10 to the power of 8? Yes, 3 times 10 to the power of 8. And then the distance is the whole path followed, right? So you're going to take this whole thing. Okay, and this is actually the circumference, right? But is it the full circumference? No, we're only talking about half a circle. For the circumference is usually 2 pi r, and since we're talking about half a circle, it's a semicircle, it's half of 2 pi r. So you could just say pi r. Okay, so pi times the radius, so pi times 1.5 times 10 to the power of 8, and you're going to get 4.71 times 10 to the power of 8. Then they say, and for part B, they say 1 full year. So hella, we started here at point A. Okay, by then I'm gonna draw the distance, the path traveled in red. We went the full circle and we came back to point A. Okay, the radius as usual is 1.5 times 10 to the power of 8. Okay, what would the displacement here be? Obviously the displacement will be 0. Why 0? Because we started at A and we found ourselves, where's our final position? Back at A. For the displacement, the change in the final position is 0. Okay, now for the distance, obviously the distance would be the red path, and that would just be the circumference of the circle. So the circumference is now 2 pi r because it's a full circle, so 2 times pi times 1.5 times 10 to the power of 8. Okay, and you get 9.4 times 10 to the power of 8. Okay, question 4. A particle moves along the x-axis from x1 to x2 and then to x3. Calculate the total distance covered by the particle and total displacement. Obviously the distance will be the path traveled. We went from 2, so if you want to, like, let's draw a number line, okay? We went from 2, then we went to 15. So that's 13, right? Then from 15 to 27. So to 27 over here, which is another 12. So obviously our distance traveled would be 13 plus 12, which is 25, right? Yeah, distance is 25. Okay. Then the displacement would be the final minus the initial, right? So final minus initial. So x3 minus x1, so 27 minus 2, which is also 25. Okay. A nice note, whenever you're working with motion, which is like a line like this, where it's a straight line, distance and speed will usually, distance and displacement will usually be equal if you're moving in one direction. Okay, question 25. Sorry, sure. Question 5. In a flight from departure to arrival, a jet airplane flies a distance of 4,800. This flight is scheduled to be 12 hours. What's the speed? Speed equals distance divided by average speed equals distance divided by time. Okay, so 4,800 divided by 12, you get 400. Okay, 400 kilometers. No, don't forget the unit. Kilometers per hour. Okay, is that correct? Yes. Okay, question 6. A and B are 30 centimeters apart. Using a tortuous path of length 50 centimeters, a turtle starts from B and needs 20 seconds to reach A. So the turtle didn't go this red path, it used the tortuous path. Tortuous, yani the distorted path, okay? The dotted path, okay, which is 50 centimeters. Find the average speed. Again, average speed equals the distance divided by the time. The distance the turtle went was 50 centimeters divided by the time, 20 seconds. Okay, so it's going to be 2.5, and the unit will be centimeter per second because the distance is centimeter. Then for part B, they say determine the average velocity of the turtle and represent its velocity by a vector when appropriate. Okay, blah, 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 blah. Okay, average velocity, okay, is equal delta x over t, right? So the change in displacement divided by the time. Okay, displacement. What's the displacement from B to A? Okay, 30. So if it were to take the straight path, okay, the change in position is only 30. It's the straight path. The shortest path is 30. Okay, so actually delta x will be 30. And the time, again, is 20 seconds. Okay, so you're going to get 1.5 centimeter per second for the turtle. Then they said represent this velocity by a vector. Okay. Yeah. Okay. The vector in this case, since we're moving from B to A, it would be velocity of BA. Like this. I think. Is that correct? It's in the direction of BA with a magnitude 1 point. Yeah, okay. They won't ask you about vectors. To draw vectors and stuff because that's not in our required material. A man goes around the field once at an average speed of 5 meters per second, and a second time at an average rate of 4 meters per second. What is his average speed in the two round trip? Okay, if you add 4 plus 5 and divide by 2, even though that might seem like the average, the obvious way to do it, then no. Okay, look. Always remember average speed equals distance divided by time. Okay, so the average speed for the first one is 5, right? Equals the distance divided by time, right? We can call it time. It's the same distance because we're going around the same field. Then for the second one, 4 is the speed. The speed was 4 equals the same distance divided by time 2. Okay, and we know that the average speed of the whole thing, okay, the whole speed, if we're going around it twice, okay, would be the same distance. We can call it 2d, right? Divided by the time needed for the first one plus the time needed for the second one, right? Because speed is distance divided by time. Average speed is distance divided by time. What is our distance? It's 2 times the distance we're using here because we're going around the field twice. Okay, he went twice, so it's 2d. What is the time? It's the time we took here plus the time we took here, right? So t1 plus t2. Okay, can I find out what t1 and t2 are? Yes, I can. Okay, t1 in this case would be d over 5. Okay, then t2 here would be d over 4. You just swap the 4 and t2, and here you just swap the 5 and t1. So d over 4. Okay, so in this case here, I can substitute t1 and t2 with d over 5 plus d over 4. So average speed would be equal to 2d over d over 5 plus d over 4. Okay, can we simplify this down here? Yes, we can. It would be 2d divided by, multiply each one by 4 here, multiply each one by 5. If you multiply by 4, you get 4d. This one by 5, you get 5d over 20. Okay, so you're going to get average speed equals 2d over 9d over 20. Okay, can you simplify this? Okay, it's going to be the same as saying 2d divided by 9d over 20, which is the same as saying 2d times 20 over 9d. Okay, cancel d with d. You're going to get 40 over 9, which is 4.44444444. Okay, that's it's a bit confusing, Miss Hani. Physics. Question 8. A particle moves along the x-axis from x1 to 2 meters to x2 16 meters in 7 seconds. The average, define average velocity. Average velocity, you just say displacement divided by the time. Okay, how do they say displacement divided by the time? Yeah. Okay, calculate it. We just do 16 minus 2 divided by 7, which is 2 meter per second, 2.00 meter per second. Okay, please pay attention to significant figures. Please. Thank you. A jet airplane may fly about 1,000 kilometers per hour. What does this value represent? Okay, they gave you the velocity. or speed, they gave you the speed at a certain instant. So we call this the instantaneous speed that the jet airplane can attain. Okay. So yani, another way you could look at it is like they said it may fly about 1,000 kilometers per hour. So it's like them telling you the plane might reach 1,000 kilometers per hour. So at a certain instant it might reach 1,000. So what is this about? We said instantaneous speed. I remember this coming in our AMSs. Question 10. Although the cheetah is without a doubt the fastest ground runner, it can only maintain an incredible speed of 110 kilometers per hour for about 175 meters. How long is that? Okay, average speed equals distance divided by the time. Okay, the distance in this case is 110. No, it's not. Sorry. It's 175. Okay. No, it's not 175. It's 0.175. Okay, pay attention to the unit. Here they use kilometers per hour, but here they give you meters. For converted to kilometers by dividing by 1000 and you get 0.175. My average speed 110 equals the distance 0.175 divided by the time that we're trying to find. How do we find the time? Just time equals 0.175 divided by 110. And you get, I forgot what you get, 0.016 sorry, 0.0016 hours, which is 5.73 seconds. To convert it to seconds, you multiply by 3,600. Okay, they didn't specify the time you should keep it, so I think if you just kept it in 0.0016 hours, you should get it correct. Okay, you're gonna need the answer for part A for part B. Okay, so here we got 0.0016 hours. Okay, if a cheetah is in a chase after a gazelle running at 50 kilometers per hour, how far should it be from its prey to guarantee a fruitful chase? Okay, to guarantee a fruitful chase, yani, it manages to catch up to it. This is how I looked at it. I said you have a cheetah over here, okay, at this point here, and then you have the gazelle over here, okay, and the gazelle is moving at 50 kilometers per hour, right, and the cheetah is moving at 110 kilometers per hour. The distance covered by the gazelle would be 50 t, right? Why 50 t? Because speed equals distance divided by time. So the distance would be the speed times the time, which is 50 t. So here it would be 50 t. Okay, here the cheetah would cover a distance of 110 t, right? So I forgot to add here, it's 50t plus the starting position x naught, okay, because we started the gazelle in front of the cheetah, right? The gazelle started like ahead, if you get what I mean. This x node is where they're gonna meet up, okay? So we want to find this x node, and we know that if they're catching up to each other, or like if they meet, that means this 110t, the distance traveled by the cheetah, would be equal to the distance to the distance traveled by the gazelle. So you will say 110t equals this 50t plus x naught. Okay, you take 50 to the other side, you're gonna get 60t equals x naught. And what is the time? I know this is very stupid, but what is the time? 0.016 hours. Okay, so we just do 60 times 0.0016 equals x naught, and you get x naught is how much? 0.096 kilometers. Let me double check this. 60 times 0.0016, you get 0.096, and this is in kilometers, so x naught equals 0.096 kilometers, which is 96 meters. Okay, question 11. What is instantaneous speed? You could just say it's the speed at a certain instant. Okay, how fast an object moving is at a specific instant. Okay, what is the instantaneous velocity? Okay, instantaneous velocity is the velocity at a certain instant. It's defined as the instantaneous speed in a specific direction. Oh, okay. Because you know velocity is just speed in a direction. So instantaneous velocity would be the instantaneous speed in a specific direction. Okay. What does it say? How is it represented on the diagram? If they ask this, okay, you can just say it's a vector. Okay. It's wow. Okay, that's a lot. You could just say it's a vector whose magnitude is yeah. By the way, the magnitude, instantaneous velocity, I think they call it like this. The magnitude of it is equal to instantaneous speed, because the instantaneous speed. Okay, always the magnitude of the instantaneous velocity is equal to the instantaneous speed, because I think we used this in one of the quizzes. Okay, so the positive value of the instantaneous velocity is actually equal to the instantaneous speed. Okay, defines the term uniform rectilinear motion, URM. It's the motion at a constant speed in a straight direction. Okay, so the instantaneous velocity has the same value during a certain time interval. Okay, we call it uniform rectilinear motion. It's defined as motion in one direction and at a constant speed. Okay, what can you say about a car moving at, okay, they said due north is a positive sense, 2 meters per second squared due north. You could say it's accelerating by 2 meters per second every second, right? The car accelerates 2 meters per second every second, and since we're moving north, it's in the positive sense, right? Negative 2 meters per second squared due south. Yeah, wait, so for part B, negative 2 meters per second squared due south, okay, it would be accelerating in the negative sense. Okay, look, here's how I do it, okay? If the acceleration is negative and I'm going in the negative direction, negative, that makes a positive, okay? Positive. So if it's a positive, that means I'm accelerating, okay? But accelerating in what direction? South, so in the negative direction, okay? So here, accelerates in the negative sense. And then here, it's positive, positive, that gets me negative. So I'm decelerating, okay? In what direction? North, so the positive sense. So decelerating in the positive sense, okay? And obviously at a rate of 2 meters, okay, you can just put that in. Question 15, define average acceleration. Average acceleration would be the change in velocity over time, divided by time. Okay, the change of an object's velocity elapsed in a certain time interval. Okay, the speed of a car changes from 10 to 25 in 5 seconds. What's the acceleration? Acceleration equals velocity final minus velocity initial over the time. So 25 minus 10, which is 15, divided by 5 equals 3 meters per second square. Always remember the unit. Question 16. Define the term uniform accelerated motion is the motion of a constant acceleration in a straight direction. Okay, so it's a body said to be uniformly accelerating if its velocity changes by equal amounts and equal time. Okay, wow. Okay, wow. Okay, same thing. You can just say, okay, if its velocity is changing by equal amounts and equal time intervals. Just say that. It's a great question, I think it comes in the multiple. Okay, the position time graphs of 3 particles are shown below. Use the position time graphs to describe the motion of the particles. Okay, here x is the same. Okay, so the displacement is not changing, so obviously the object here isn't moving if it stays at 4 meters. If the position stays at 4 meters, then obviously it's at rest. Here the motion is changing at a constant rate. Okay, so it's moving at a constant velocity. Okay, so it's moving at a constant velocity. Here, since it's a straight line, it was constant velocity. Here it's curved, so the velocity is not constant. It's going up, so the velocity is increasing, but here you say it's accelerating. Okay, it's accelerating. If it's curved, you say it's accelerating. So in particle A, it's not moving since it's horizontal. In particle B, it's a constant speed since it's a straight line. But in particle C, it's accelerating. The velocity is increasing. Okay, because it's a curve. If it's curved, it's increasing. For question 18, the graph below illustrates the motion of a hockey puck in 8 seconds. I feel like they could get something like this in the written. I don't know, but صراحة, for now, my predictions for written for now is going to be something that has to do with chapter 9 100%. I don't think they're going to get chapter 7 or 8 in the written. I think they're going to get chapter 9 or chapter 2 in the written. The graph below illustrates in 8 seconds. Okay, you can just go from the graph. What's the position at 0 seconds? 2. At 0.5 seconds, it's still 2. At 1 second, it's still 2. At 2 seconds, it's like 2.5. At 3 seconds, it's 3. At what time is it at 0? So we go to 0 at 4.5. Then at 6.5, it's -4. Then at 8, it's 0 as well. Okay. Question. Is there another part? What is the average velocity in the time interval 1 second, 3 seconds? Can I scroll down? Okay. In 1 second, 3 seconds. So at 1 second, velocity would be x final minus x initial divided by that time, right? So at 3 seconds, it's at 3, right? So at 3. Then at 1 second, it's at 2. So minus 2. Okay. Divided by the time. 3 minus 1, right? Time final minus time initial. 3 minus 1. 3 minus 1. Okay, you get 3 minus 2, 1 over 3 over 2. You get 0.5 meters per second. Is this correct? 0.5. Okay, question 19. The distance. Okay, this comes 100%. It will come. The distance time graph of a moving object is plotted below. The tangent to the point at A, 5 seconds 10 meters, passes through the point 2 seconds 0 meters. What is the speed? When they give you the 2 points like this, all you have to do is just do final. Whatever. It doesn't matter. Okay, it's speed, so you're always gonna get positive. Okay, you can do 0 minus 10, 10 minus 0. It doesn't matter. 0 minus 10 over 2 minus 5. Okay, you're going to get 10 over 3, negative 10 over negative 3, which is just 10 over 3, which is going to be 3.3. Okay, so 3.3. Okay, question 20. The graph below represents the VT graph of a motorcycle in 24 seconds. Okay, using the VT graph, complete the following table. Okay, at time 0, it's 0. At time 2, it's 24. So here, 16, 12. No. 6, 12, 18, 24. Okay, yeah, so here 12. Because it's four blanks. It's 24 divided by 4, 6. So each blank is 6. So 24, 18, 12, 6, 0. Okay, at 4 it will be 24. Oh, Aslan, they gave us 24. Okay, so they are kind of, okay. You didn't have to divide. المهم, at 7, 5, 6, 7, 7, it's over here. In between 24 and 30, it would be 27. At 9, it's 30. At 10, it's 30 as well. At 12, it's 30 as well. At 13, it's 18. At 15, it's 0. 16, 0. 17, 0. 19, negative 12. 20, negative 12. 22, negative 6. 24, 0. Okay, so if this does come in the written, this would be a nice 4 marks. Okay, that would be easy marks. No need to lose anything. Find the time intervals where. Okay, so let me take this up. Oh. Find the time interval where the velocity is positive. Okay, where is the velocity positive? It's positive from 2 seconds to 13 seconds. Okay, so you could just say 2 seconds, 13 seconds. Or do they count 0 seconds? Wait, let me see. I think you're supposed to say 0 seconds actually. 0 seconds. 0 seconds, 30 seconds. What do they put in the answer key? 0, 17. 0, 17. 17. So they want it before it goes negative. Okay, so I guess how you could put 17. Okay, so the velocity is positive 0 seconds to 17 seconds. For part 2, they say the velocity is negative. Where is the velocity negative? Obviously from 17 to 24, right? Is that correct? 17 to 24. Okay, then they say the velocity is positive and decreasing. What is the rate at which the velocity increases in this case? Okay, the velocity is positive and decreasing. Positive and decreasing. When is it decreasing and it's positive? Obviously from here, from 12 to 15. Okay, what is the rate at which the velocity increases in this case? Okay, what is the rate? We went from 12 seconds, 30 meters per second, then to 15 seconds, 0 meters per second. Final minus initial, so 0 minus 30 over 15 minus 12, because acceleration is velocity final minus velocity initial over time final minus time initial. Okay, it's going to be negative 30 over 3, which is negative 10 meter per second square. Okay, how can we describe the variation of speed in this case? I don't know, how can you describe it? That's it. Okay, you could just say it's decreasing, I guess. How can you describe the variation of speed? Just say it's decreasing by 10 meters per second every second. Okay, the velocity time graph of a moving object is shown below. Describe the state of motion in the phases AB, BC, CD. Obviously in AB it's increasing at a constant speed. BC it's not moving, so it's at rest, and then CD it's decreasing at a certain. Okay, AB it's accelerating, BC it's moving. Wait, sorry, it's not position. AB it's increasing the velocity, so it's accelerating, then BC it's moving at a constant velocity, right? It's not 0. If it was 0 it would be, if it was at rest it would be a 0. Here it's not 0, it's just constant velocity. Then CD we said is decelerating, accelerating, going down, right? Yes. Okay, then question 22. What is the average acceleration between time 10 seconds and time 30 seconds? So between here and here. Okay, final minus initial. This final is 40. Initial is 20 over the time, which is 30 minus 10. So you're gonna get 20 over 20, which is 1 meters per second squared. Okay, yeah. The velocity time graph of a moving car is shown below. Calculate instantaneous acceleration at t equals 6 seconds. Okay, when they say instantaneous and you have a curve, okay, you're gonna want to draw the straight line. Okay, you want to draw the tangent. Okay, this could come. You draw the tangent at that point. Okay, and in this case, since our point t equals 6 seconds, it's actually a straight line. This part of the curve is actually a straight line. So you can actually take any point on the straight line. And to make things easier, we're going to take this 6 seconds and we're going to take this one over here, the 8 seconds. Okay, so at 6 seconds we have 6 meters per second. And then at 8 seconds we have 4 meters per second. Obviously you take final minus initial, so 4 minus 6. And then 8 minus 6, which is going to be negative 2 over 2, which is negative 1 meter per second squared. Is this wrong though? Yeah, negative 1. Okay. Question 24. Okay, these are all grids, for these are all something, these all could come. What is the displacement between t equals 4 and t equals 13? T equals 4 is over here, t equals 13 is 1, 2, 3, over here. Okay, so we want the displacement from these two. Okay, remember, when we want displacement on a VT graph, okay, always when we want the displacement between a VT graph, you calculate the area. How do you calculate the area of the shape? It's a trapezoid. So we do b1 plus b2 over 2 times the height. Base 1 will be from 6, wait, it's been 4 seconds. Ya Rabbi. Okay, 4 seconds is over here. 4 seconds. So over here. Okay, so from here to here, obviously you connect these 2 points. We want the area of the shape. So from 4 until 13. Alright, so base 1 would be 9. Base 2 would be from over here, which is 9 to 13, 4 over 2 times the height. The height is from, is this 2, 4, 6, 8. So it's 18 times, sorry, no, 8 from 18. Here's negative 8. No, sorry, negative 12. Here is negative 12. So the height is 30. Yeah, 30. 18 minus 12 is 30. Okay, so you cancel 15. 9 plus 4 times 15. 13 times 15. 3 times 150. It should be 195. Oh, I'm seeing 87. Okay. Let's see. What did I do wrong? So after taking a look at this, apparently when drawing your figure, okay, so we want it from here, from 4 to 13 up here, okay, here it's 13. So you can't connect it all, okay, because you're going through the 0 line. Okay, you can only go down until 0, okay, and continue to where the graph ends. So this is your first trapezoid. Okay, but we want this also, we want the 4 seconds, right? They said 4 seconds. So for this 4 second part, you can't connect it all the way and go up. No, because you can't go through 0. You're not allowed. Okay, so the 4 seconds part, I'm missing out this part from 4 seconds to 6 seconds. Okay, between 4 seconds and 6 seconds, I can just draw this triangle over here. So you're gonna get these two shapes. You're gonna get this triangle and this trapezoid. Okay, and this triangle here, from 4 to 6, so the base is 2, and the height is from negative 12 to 0. The height will be negative 12. Okay, that's just how it is. If it's under the graph, then it's negative. So you're gonna get negative 12 times 2 divided by 2. You're gonna get the area of this triangle is negative 12. Then this one here, the trapezoid, okay, simple. The base over here from 6 to 13 is gonna be 7. Then the base from 9 to 13 is gonna be 4. So base 1 plus base 2, so 7 plus 4 over 2 times the height, which is 18. Okay, you're gonna get 99. Okay, so if you add 99 and negative 12, you're gonna get 87, like they got here. Okay, this is a very bad one. I don't think they're gonna get it, Saraha. But that's it. At 11:30 a.m., a yacht cruising at a constant velocity of 15 meters per second towards the shore is spotted at 4,500 meters from the land. I'm gonna take this into open board. Okay, determine the equation of motion of the yacht taking the shore as the reference. Deduce its position at 11:36 a.m. Find the time it takes to reach the shore. What will be the clock reading at that instant? So whenever they say equation of motion, you usually think URM or UARM. An equation of motion, since we're talking about constant velocity, is URM. And the URM equation is x equals vt plus x naught. This comes from v equals x divided by t, so you know. And the x node is because it's delta x. Delta is x final minus x initial, and x zero yani x initial. Okay, so x equals vt plus x initial or x node, whatever you call it. So that's the equation of motion. But we have to plug it in. We have to see the conditions. They said take the shore as the reference. What is our velocity? It's 15. So 15 t plus x node. Okay, where is our starting point? 4,500 meters from the latter. Okay, لا يعني the shore. Okay, so if I were to draw, like, this is the water, right? And this is the shore over here. Let's call this the shore. Okay, and the boat or the yacht is over here. Okay, it's cruising and is going. It's 4,500 meters away from the shore. So what will the initial position be if you take the shore as the reference? It will be negative 4,500 because it's 4,500 meters away. So x equals 15t minus 4,500. Okay, deduce its position at 11:36 a.m. So since we started at 11:35 a.m. and now it's at 11:36 a.m., the time elapsed is 1 minute, right? So t equals 1 minute, okay, which is how many seconds? 60 seconds. And since we're working with 15 meters per second, you need to use seconds, okay? So x equals 15 times 60 minus 4,500, and you're gonna get negative 3,600, okay? Find the time it takes to reach the shore. If before continuing to part C, negative 3,600 means now if you were to draw the boat, okay, and the shore is over here, you would say it's 3,600 meters away from the shore. So if you get negative 3,600, say 3,600 meters away from the shore. Okay, then part C, find the time it takes to reach the shore. What will the clock read at that instant? So when it reaches the shore, then obviously x will be 0. صح? It won't be away from the shore. If it reaches the shore, خلاص. Where we reach the shore, so x is 0. Okay, so if you use our equation here, 15t minus 4,500, it will be 0 equals 15t minus 4,500. So 15t equals 4,500. So t equals 3,000. Wait, no, 3,000, 300. 300 seconds. Okay, since we're working with minutes, you have to convert this to minutes. So 300 divided by 60 is 5 minutes. So what will the clock read at that time? We started at 11:35. After 5 minutes, just 11:35 plus 5, you get 11:40. Right after 5 minutes. Is that correct? Yes. Okay, now question 26. Arnold and Richard are 140 meters apart. Arnold can run at a speed of 8, while Richard can run at a speed of 6. If the two boys run at the same instant straight towards each other, when and where do they meet? And then they say when the boys meet, Richard keeps running, but Arnold stops for 5 seconds before running after Richard. Where and when can Arnold catch up with Richard? Okay, so I'm going to take this into open board because, again, we need some space to work. Okay, so imagine this is Arnold over here, and this is Richard over here, and they are 140 meters apart. Okay. So how you're gonna do it is we're gonna write the velocities. Okay, Arnold can run at a speed of 8 meters per second. So let's say Arnold is running to the right at plus 8 meters per second. So you have to assume the right side is the positive direction. And then we said Richard at a speed of 6. So he will be negative 6 meters per second because he's going in the opposite direction, right? Now we have to take a point here as the origin. Okay, since we're taking Arnold, he's to the left of Richard and he's moving in the positive direction. That means Richard will be the origin. So in this case here, the origin is Richard. Please, if you have a written part, specify that what your origin is. Okay, origin is Richard. We have to find the x, you know, vt plus x node, right? If Richard is the origin, so his x will be negative 6t plus x node. Since he's at the origin, x node will just be 0. Then for, let's say x of Richard. How about the x of Arnold? The x of Arnold will be 8t minus 140. Why minus 140? Because Richard is the origin and he's 140 meters to the left of origin. So minus 140 would be his initial position. Okay, now we want when do they catch up, right? When do they catch up? You equate these two. 8t minus 140 equals minus 60. And if you solve this, you're going to get t equals 14 seconds. Okay, as the t equals 10 seconds. 10 seconds. They said also where do they meet. So I can just plug in this 10 seconds into anything here. So all you have to do now to find where, we just plug in this negative 10, this 10 seconds into any of these two equations. It would be easier to plug it into Richard's one. So x of Richard would be negative 6 times 10 equals negative 60 meters. Okay, we got negative 60. Okay, here they got 80. Why? Because they took Arnold's initial position as the origin. So negative 60 meters with respect to Richard, it would be over here, right? 60 meters to the left of Richard. But if they took Arnold as the origin and they got 80 meters to the right, let's say this was the origin, they got 80 meters to the right of Arnold, which is also here, right? Because this whole thing is 140, you have 60 here, 80 here. So we got the same answer. So if you take Richard as the origin, you get this answer, you get it correct. And if you got Arnold as the origin and you got this answer, you'd also get it correct, okay? And then they said, what was the second part? When the boys meet, Richard keeps running, but Arnold stops for 5 seconds before running after Richard. Where and when can Arnold catch up with Richard? Yeah, for part B, when the boys meet, okay, Richard keeps running, but Arnold stops for 5 seconds before running after Richard. Okay, so let's say they meet here. Oh, no, they met here, right? So Richard continues running, but Arnold stops for 5 seconds. Okay, we know that x equals vt, right? And if Richard is running at a speed of 6 and Arnold waited 5 seconds, so we know that the distance traveled by Richard in those 5 seconds is 30 meters per second. Okay, so we can create two equations, right? For Richard, the position of Richard is vt plus x naught, right? And his velocity is 6, and we don't know the time, but we know that his starting position was 30 meters away from Arnold, right? Because he waited 5 seconds for 30 meters now. Why did I write 30 meters per second? The meters. Okay. Then Arnold, we know, is running at a speed of 8 meters per second. For the x of Arnold, he's starting at the 0. He's starting at the initial starting point here. So his speed will be 8t, and x node will be 0 because he started at 0. So now we want them to catch up again. So that means this position of Arnold should be equal to the position of Richard. So 8t should be equal to 6t plus 30. And you're going to get 2t equals 30. You're going to get t equals 15. And they said where and when. So we want where. We just plug in 15. So you can plug it into 8t or 60 plus 30. So 8 times 15, you get 120 meters. Okay, is that the answer? So 120 meters. And you can specify from where they first met. Huh? Question 27. A particle initially at the origin of an x-axis moves uniformly at 3 meters per second in the negative direction. Okay. What is the two significant figures? The position after moving for 5 seconds. So for position, okay, you always use x equals vt plus x naught. And since we're saying it starts at the origin, for the position, the initial position is 0. If I do x equals negative 3 times 5, because they said in the negative direction, huh? Okay, you get negative 15 meters. Okay, so negative 15 meters from the origin. There you go. Okay, 28. A car starting from rest accelerates for 5 seconds, okay, at the rate of 4 meters per second squared, and then moves at a constant speed for 4 seconds. From the above word description, plot the graph of this motion, VT graph. Okay, it starts at rest, it accelerates for 5 seconds. Okay, so for 5 seconds, at the rate of 4 meters per second squared. We know that velocity is equal to acceleration times the time, plus the initial velocity. But since we started from rest, we don't have to write this initial velocity. For acceleration times the time. Okay, so it will be 4 times 5, so 20. Okay, so that means during these 5 seconds, it reached 20. Where's 20? Over here. So like this. Okay, now connect these two dots. Okay, obviously with a straight line. Okay. Moves at a constant, okay, and then it moves at a constant speed for 4 seconds. So now it stays at this 20 meters per second for 4 more seconds. So from 5 until 9, stays at a constant speed. So this should be correct. Okay, it's somewhat correct. Okay, then they say at which interval does the formula x equals half at squared apply? Okay, x equals half at squared is used for when you have UARM, so constant acceleration. Okay, where do we have a constant acceleration here? we have a constant acceleration from 0 seconds up until this point here at 5 seconds. Okay, so we can say from 0 seconds to 5 seconds. Okay, at which interval does the formula x equals vt apply? This means constant velocity. Okay, URM. And where do we have constant velocity here? We have constant velocity from this 5 seconds up until 9 seconds, right? So from 5 seconds, 9 seconds, if I'm not wrong. Yeah. Okay. Then they said part D, calculate the total distance covered by the car during the 9-second interval. Okay. Can we find the distance or displacement when you have a VT graph? Yes, you can. You can just find the area, right? So you can just make this a trapezoid over here. Base 1 is 9, base 2 is 4, from 5 to 9. The height is 20. So 9 plus 4, base 1 plus base 2 over 2, times the height 20, you're going to get 130. Yeah, here they used x equals half at squared, and they used, well, okay, I guess you can do this. Okay, they used the formulas that they gave you here. So you can find the distance for the first 5 seconds, then find the distance for the next 4 seconds, okay, and then add them up. So they used x equals half at squared, okay, which is 50, and then they used 20 times 4, 80 for vt, okay, and they added them up, they got 130. Okay, calculate the velocity at t equals 3, t equals 7. Okay, at t equals 3, okay, and at t equals 7. So look, my advice to you, never get something from the graph unless they specifically tell you from your graph. Okay, so we know that in this straight line period, it's accelerating at a rate of acceleration a equals 4 meters per second squared. Okay, we know that velocity equals acceleration times the time. So this acceleration 4 times the time, 3 seconds, okay, you get 12. Okay, then at 7 seconds over here, we know it's a straight line, so it's a constant velocity, so you can just say it's 20. V equals 20. So I got V equals 12 meters per second, and then V equals 20 meters per second. Okay, determine the highest velocity of the car in kilometers per hour. So we know that the highest velocity is 20, right, up here. Change it to kilometer per hour. To change from meters per second to kilometer per hour, you multiply by 3.6. 20 times 3.6 is 72. 72 kilometers per hour. Okay. Question 29. A car starting from rest accelerates for 10 seconds at a constant rate of 4 meters per second squared. What is velocity at t equals 6 seconds? Okay, so they gave us acceleration, they gave us the time, okay, and it starts from rest, so v naught equals 0. Or you could say u equals 0. Okay, we know v equals at plus u, so v equals acceleration 4 times the time 6. We don't care about this 10 seconds, we want the 6. Okay, plus 0, so you get 24. Am I wrong? No. Okay, question 30. A car moving at the speed of 4 meters per second accelerates at 2 meters per second squared, okay, for 3 seconds, then moves at a constant speed for 2 seconds, and finally applies the brakes, hence decelerating uniformly to stop a further 5 seconds. So let's think a bit, okay? We know v equals at plus u, okay? So it starts moving at the speed of 4 meters per second, given. After 1 second, obviously, velocity equals, since it's starting, so u is 4, because it's the initial, okay? Acceleration is 2 times 1 plus 4. So you get 6. Then at 2 seconds, same thing. 2 times 2 plus 4. Then 2 times 3 plus 4 for 3 seconds. So you get 8, 10. Okay, 8, 10. Okay, then moves at a constant speed for 2 seconds. For the next 2 seconds, 4 and 5, it's now a constant speed. So 10, 10. And then finally applies the brakes, decelerating uniformly to stop in a further 5 seconds. Okay, we kind of need to know the rate of acceleration. So we know that we were at v equals 10, right? How do we find acceleration? It's velocity final minus velocity initial over the time. Okay, our final velocity, obviously, if we decelerate uniformly, it applies the brakes, and our final velocity is 0. And our initial velocity is 10, right? We're going from 10 to 0. So 0 minus 10 divided by the time taken, 5, which is negative 2 meters per second square. Okay, now can I find the velocity for each one? Yes, velocity equals acceleration times time plus u. And since our initial velocity is u, which is 10, we're starting at 10, we can just plug in now each time. Okay, so you can, since you know it's decelerating by minus 2, you can just go 8, 6, 4, 2, 0, because obviously it's 2. But if you want to be professional, okay, we're not going to use 6, 7, 8, 9, 10. We're going to use 1, 2, 3, 4, 5. Because this is another set of motion. So you do 1 times, you do negative 2 times 1, -2 times 2, -2 times 3, and so on and so forth, and you're going to get 86420. Okay, so now we completed the table. Okay, we're going to use it for the second part. Okay, plot the VT graph. Let's plot the VT graph. Okay, I'm not going to plot it. Actually, just look at the answer key. It's taking too long. Yeah, you just go. We started at, our initial was 4. Actually, I'll plot it. Okay, take this over here. We have y-axis, x-axis. Y-axis will obviously be v, meters per second. Then here, time, put seconds. Please make sure to put the units, huh? You get marks for this. Okay, so let's say we start at 4 over here. Okay, then we go up to 10. So 6, 8, 10. 10 is over here. So in how many seconds? In 3 seconds. So 0, 1, 2, 3. So we're gonna go up here to 10. You just connect them. Okay, I think the term 1 final was like this. I'm not sure. Or term 2. Okay, then it stays constant until 5 seconds. So we're gonna stay until here. Stay constant, straight line now until 5 seconds. Okay, then it's gonna decelerate to 0 at 10 seconds, right? 6, 7, 8, 9, 10. 0. You connect these two dots. There you go. There you go. Okay, is this the same thing? Yes, it is. Okay. Using areas, find the distance covered during the first 3 seconds of motion. Okay, during the first 3 seconds, it's a trapezoid, right? A trapezoid. I'm gonna use blue. Okay, it's a trapezoid. Our bases are the straight sides, so it's gonna be these two blue sides. Okay, so we're gonna have 4 as my first. Oh, not like that. We're gonna have 4 as my first base over here, and my second base over here will be 10. Okay, so base 1 plus base 2 over 2 times the height. So 4 plus 10 over 2 times the height. The height will be the distance in between both bases, and it's going to be 3. Okay, so 4 plus 10 is 14, divided by 2, 7. 7 times 3, 21. So is that correct? 21. They used, okay, yeah. And then they said using the acceleration, okay. Now they want you to use the formula. Okay, since we know the velocity is increasing at a constant rate, that means the acceleration, we know what the acceleration is. We know the acceleration is 2, right? Okay, how do we find x when we have the acceleration, the time, and the initial velocity? We know half at squared plus ut plus x naught, right? So x in this case would be half times acceleration 4 times time squared. The time is 3 squared, so 9, plus ut, so u, which we know the initial velocity was 4 times 3. Okay, and x naught is 0 because it's not really given. Okay, so you're gonna get half times 4, 2 times 9. You're gonna get 18 plus 12. Oh, why am I getting 30 and not 31? No. What? Wait, what does I get? Okay, after looking at the answer key, my fault. Acceleration is 2 and not 4. I don't know why I put 4. Okay, acceleration is 2. Okay, half times 2 times 9, because 3 squared is 9. Okay, times 3, 3 squared is 9, plus ut, which is 4 times 3. So you get 9 plus 12 equals 21 meters. Okay, same answer, right? Please don't forget the unit, huh? Same answer. So using the formula, using the areas, we got the same answer. Using the acceleration between, okay, we got this. Question 31. A particle is initially found at 1 meter to, this one comes at 1 meter to the right of the origin of an x-axis. So x node is 1. Initially moving at 2 meters per second, so u is 2, initial velocity. The particle accelerates at a rate of 3 meters per second, a is 3, time equals 4. Position, we have x node, we have acceleration, we have time, we have u. What do we use? We have x equals half at squared plus ut plus x node. Okay, half times acceleration, which is 3, times time squared, which is 4 squared, plus ut, initial 2, times the time 4, plus x node 1. You put this in a calculator and you get 33. Half 3, okay, yeah. Okay, you know what, I'm gonna write down the formulas for you. URM, it's x equals vt plus x node, and then UARM, from the ones I remember, v equals at plus u, x equals half at squared plus ut plus x node. Okay, and then we have v squared minus u squared equals 2ax. I think it's just these three. Okay, and there's a fourth one, x equals u plus v over 2 times t. Okay, this you never really use this, but these are the three most important ones. Okay, uh, so don't screenshot this yet if you want. Okay, but I'm gonna continue writing for every chapter the formulas over here so we can have like a complete formula list. Uh, okay, now question 32. A particle is initially found at 1 meters, so x node is 1. Okay, initially moving at, so u equals 2. Particle accelerates, a equals 3, time equals 4. Same formula, x equals half at squared plus ut plus x node. Okay, please, this question, at least one of them would come. 100%, because they're both grids, or they've come, no, this isn't a grid, but they've come in every physics AMS we've done that had to do with these chapters. Okay, so just plug it in, half times acceleration 3 times time squared 16, 4 squared 16, plus ut, it's the initial velocity 2, times the time 4, plus x node 1. What the fuck is that? Okay, you get 40. You get 40. Okay, what did they ask? What is the nearest m? The position of the part. How did they get? Hold up. Why did they, how did they get 5,400? They couldn't ask question 33. Okay, wait. You don't get 40. These aren't the same. This is the same question as this. I think there's supposed to be a different question 32 here. Yeah, okay. خلينا نصعب على 32. But we're just gonna go 33. Okay, a cyclist is a race. I don't even know the question. How? خلاص question 33. A cyclist is at a race. At t equals 0 seconds, the start is fired. Determine instantaneous acceleration at t equals 2 seconds. Okay, you just get it from the graph. 2, 3. Is it 3? Slope of the graph at t equals 2 seconds. What? Okay, my fault. So, since it's a straight line, that means it's a constant acceleration. And if it's a constant acceleration, so it's a straight line, just take the slope of the line. Okay, the slope here will be any 2 points. We can just take 5 seconds, 10 meters per second, and 0.8 seconds, 0 meters per second. Okay, so find the slope. Find minus initial, 10 minus 0 over 5 minus 0.8. You get 10 over 4.2, which is 2.4. Okay, so that means the acceleration for this whole line is 2.4. So at any instant here, it would be 2.4. Okay, so 2.4. Then they ask, determine the distance traveled in the first 10 seconds. Okay, in the first 10 seconds, over, okay, yani, this is a trapezoid. So base 1 will be from 0.8 until 10, so it will be 10.2. And then base 2 will be from 5 to 10, which is 5, so 10.2 plus 5 over 2 times the height, which is 10. So you're gonna get 7.6 times 76, I think. Oh, okay. Okay. 10.2 plus 5, okay, 15.2 divided by 2. Oh, okay, that's interesting. Okay, let's take a small look here. D equals half 10. Okay, base times, okay, 4.2 is the base. Wait, okay, so they took this why? What? Okay, guys, my fault. The length from 0.8 to 10 is 9.2 and not 10.2. So you get 71. My fault. Okay, then they say, I think the reaction time. Okay, determine the reaction time based on the VT graph. Obviously, the reaction time is just going to be how long did it take for this guy to start moving. And over here, it took him 0.8 seconds. Is that correct? Reaction time is the time the cyclist remains stationary, which is 0.8 seconds. Then they say, complete the graph to describe the motion if he manages to stop just before hitting the up. Okay, for part C, I didn't really read the question. So look here. So he sees it, and he brakes urgently, okay? And we know that this guy's reaction time that we found here in part I is 0.8 seconds. So he continues here. Sorry, let me draw it. Let's draw it. He continues for another 0.8 seconds. So he continues over here until 10.8. So we want to know, so there's 25 meters left, right? Okay. In this 0.8 seconds reaction time, okay, can we find how much distance he traveled in that 0.8 seconds? Of course we can, Vt, right? And we know that the velocity is 10, right? So 10 times 0.8 seconds gets 8 meters. So now there's 17 meters left. Okay, there's 17 meters left, okay? We have the initial velocity, u. We know that he brakes until rest, so the velocity final is 0, okay? We have x, but we need the time. And which equation from the UARM, because we're gonna decelerate at a constant rate, has u, v, x, and t, okay? It's gonna be u, it's gonna be x equals u plus v over 2 times the time, okay? I know I did say you're barely gonna use this. Apologize. I think now you're gonna see it's important. Especially my friend Laith. Okay, he told me you're gonna use it, and I kept on saying no, you won't use it, no, you won't use it. Okay, and now you're using it. So المهم, uh, let's substitute. X is 17, right? Our initial velocity is 10. We're starting at 10. Our final is 0 over 2 times the time. Okay, so you're gonna get 5t equals 17. You're gonna get t equals 3.4 seconds. Okay, so we'll complete the graph. Okay, so if we complete the graph, it's gonna go down. So 3.4 seconds. Yani we're at 10.8 right now. 10.8 plus 3.4 is gonna be 13.8, 14.2. So over here. So connect like this. Am I correct? Yeah. So 10 plus 0.8 plus 0. There you go. Question 34. Okay. How many? Okay, we have. This is the last question for chapter 2. The graph paper below can be used to describe the motion of a pedestrian. Between time equals 0 and time equals 2 seconds, the pedestrian stands still at x equals 1. So we could say 1. Okay, between time equals 0 and time equals 2. So over here, he stays at the constant motion. Okay, then he starts to walk in the negative direction at 1 meters per second for 4 seconds. How do we find x if we have the velocity in the time? X equals vt, right? So 1 times 4 in the negative direction. So negative 1 times 4, negative 4. So we were at 1, we went down minus 4. So it's going to go down to minus 3. 1, 2, 3, minus 3. So هتنزل 4 seconds. So at the 6th second, 4, 5, 6. At the 6th second, هنكون هون at minus 3. Okay, connect. Oh, okay, connect. Calculate, okay, calculate the average speed of the pedestrian between 0 seconds and 6 seconds. Average speed is distance divided by time. Distance divided by time. So we went 1 meter, then 4 meters. So it's going to be 5 divided by 6, which is it 0.87? 0. Oh, why is it 4 meters? Distance divided by time. Oh, the distance is 4. How did I get 5? From 1 to minus 3 is 4. So you get 0.67, yeah, 0.67. Okay, then at time equals 6 seconds, the pedestrian begins to slow down, coming to rest at time equals 9. So they want the acceleration. Okay, acceleration, average acceleration is velocity final minus velocity initial over time. Okay, our final velocity, since we slowed down to rest, its final velocity is equal to 0. Okay, our initial velocity was negative 1, right? We said it's negative direction 1 meters per second, so it was negative 1. So 0 minus minus 1 على the time. The time in this case was, it took us 3 seconds. From 6 seconds to 9 seconds is 3 seconds. So 1 over 3, so 0.33. Okay. Then use the graph paper below to describe the motion of the pedestrian in 0 seconds, 9 seconds. Okay. In the first 3 seconds, he stayed at a constant x, so he didn't really move. So v equals 0 for the first 2 seconds, right? For the first 2 seconds, it was v equals 0. So let's see. For the first 2 seconds, It was like this. Okay. Then after that, he went at -1 for 4 seconds, right? So it stayed at -1. How? Wait. How? Like this? Wait. No. Where am I now? Where am I? What? Here. Okay. 2. And then he went to -1 for 4 seconds. So 1, 2, 3, 4. So for 6 seconds, he went down to -1. Or no, or was it just a straight line? Let me see. Yeah, he went straight away. He didn't decelerate. He went straight away. So 1, 2, 3, 4. So straight away, he's now at -1. So he went down and he continued at -1 like this. Okay, they didn't say he and he gradually decreased speed. No. Then after 6 seconds, what did we say? Then after 6 seconds, you draw a straight line. We said from 6 seconds to 9 seconds. 1, 2, 3. At 9 seconds over here, he went back to v equals 0. But here he accelerated, right? But in part here, he didn't accelerate. He just all of a sudden he became -1. So that's why it went down straight away. But from 6 seconds to 9 seconds, he actually accelerated. So now that he gradually increased. So you have to like slope the 9, if you get what I mean. Okay, we're done chapter 2. هلا chapter 3. Okay, chapter 3. What is the result of an interaction between two objects? This is a great question. It always comes. So they're gonna get it for you multiple choice if this comes, and obviously the answer is a force. Okay, uh, categorize categorize these forces into action at distance or contact forces. Electrostatic forces. Listen. The two action at distance. The two non-contact forces are weight and magnetic force and electric force. These three. Okay. So electric force, action at a distance. Pushing a door, it's gonna be contact. Magnetic, action at a distance. Bouncing a ball, acute contact. Weight, action at a distance. An elevator going up, that's contact. Okay, so كلهم contact. The only action at a distance are always electric, magnetic, weight. Okay, list 5 examples of contact forces. You could say the normal force, you could say friction, you could say air resistance, you could say tension, you could say maybe upthrust, normal force, tension, friction, resistance, upthrust. Yeah. A box moving along a rough surface will eventually stop. What is the force acting on the box? It's friction. And where does it act? Where does it act actually? Between the box and the rough surface. Oh, obviously between the two objects. Okay, between the box and the rough surface. So it's a box moving along a rough surface. Friction acts between those two bodies. Okay, a parachutist is descending vertically. What is the frictional force? We call it air resistance or drag. Air resistance in this case. Okay, define the weight of the body. Weight is the push. Is the for. What is it? It's the pull by Earth, right? The weight of the body is the force exerted by Earth. Okay, yeah. Okay, the force exerted by Earth on the body is what we call the weight. So always weight, it's related to the body and the Earth. What characterizes vectors in general? We have this. Ah, okay, a force. Yeah, yeah. What are the three characteristics of a force? It's the magnitude of the force, the direction of the force, and the point of application of the force. Okay, so the magnitude, the direction, okay, and the point of application. Question 8. Represent the following forces. Okay, a force of magnitude. Okay, once. Okay, you just have to draw them. Sorry. Yeah. Okay, this doesn't come. Find the resultant of the three forces. Okay, always for resultant. Okay, you always have Fx and you always have Fy. Okay, so we're gonna split each of these three forces into an Fx and an Fy. Okay, F1 obviously F1, the x of it is obviously plus 12. Okay, and the y of it is obviously 0 because it's going to the right. Okay, always remember Fx of a force is the F cosine 30. Sorry, F cosine angle, and then Fy is F sine alpha. This is only when the force, when the angle given is with the x-axis like this. Okay, but if they gave you the angle up with the y-axis, then you have to split them. You do cosine for y and sine for x. Okay, but usually they give it with the x-axis. But I'm only saying this because in the term 2 final, they got it, or was it term 1 final? I think term 1 final. They got it with the y-axis. There was problems with that. Okay, المهم, F1y is obviously 0 because the force 12 times the angle here is 0. If it's on the x-axis, then 0. Because 12 sine 0 is 0. Okay, and why is it 12? Because 12 cosine 0 is 12. Okay, المهم, let's continue now to f2. f2x is obviously 0 because 9, the angle is 90, right? 9 cosine 90 is 0, and then 9 sine 90 is 0. Okay, sorry, is 9. Is 9. Okay, so f2x is 0, f2y is 9. Okay, how about f3? Okay, f3x would be negative 15 cosine 53.13. Why negative 15? Because it's going to the left. And you know, left is the negative direction for the x. Okay, for the x, negative would be going to the left. Since it's going to the left, I have to make it negative 15. And then f3y would be, since it's going up, we don't make the y negative, we just keep it positive. It would be 15, this time sine 53.13. Okay, now how do we find the total fx? The total fx would be adding up all of these, right? So 12 plus 0 plus minus 15 cosine 53.13. Okay, then fy would be, for fy you get 0 plus 9 plus 15 sine 53.13. If you add these up, you get, I think, how much? Let's see the solution. You get the resultant 3 newtons. Okay, you get 3. Make sure to include the unit newtons. And if you add the y's, you get 21 newtons. But did they ask us to find the resultant x, resultant y? No, they want the resultant, the total resultant. How do we find the resultant? The resultant force F is always radical Fx squared plus radical Fy squared. So our resultant force here, F, would be radical 3 squared plus 21 squared, and it's gonna be, هلا they drew the resultant, but they didn't specify what it is. I remember this came in one of the written parts, and you guys forgot to draw. You got a mark for drawing, guys. Okay. How much do you get here? Let me do a calculation. You get 15 radical 2, but as a decimal it will be 21.21. And obviously in physics we don't have radicals, we keep it as decimals. Okay, 21.21. Okay, and how do we find the angle? It's always shift tan, okay, of fy over fx. So our fy is 21, our fx is 3. You're gonna get 81.87 degrees. Okay, so that's why when they drew it here, 81.87 degrees would be something like this. It's almost at 90. Okay, and it's going up. Okay, and since it's a larger force, 21.21, than all these three, so the arrow of it has to be larger than all these three. Okay, and we say 21.21 newtons. And if you want here, you can say like the angle is 81.7 or something. I don't know. They didn't specify, they just drew it. I don't understand why. Anyway, question 10. In the diagram below, 3 forces act on a ball. Find and draw the resultant R of the given forces, showing its direction and the magnitude. Okay, obviously, if it's 11 to the left and 8 to the right, then the resultant would be 3 to the left, 3 newtons to the left, because 11 minus 8 is 3. Okay, is that it? Okay, wow. Question 11. A tree is acted upon by one 6 Newton force acting north and another 8 Newton force acting east. Determine the magnitude of the resultant force and find the tangent of the angle between the resultant force and east. Okay, so east is over here and this is north. Okay, how do we find the magnitude? Well, they gave us Fy and they gave us Fx. And so we just do radical Fy squared plus Fx squared, or Fx squared plus Fy squared, doesn't matter. 8 squared plus 6 squared, and you get 10. Okay, they want also the angle. No, they want the tangent of the angle. Okay, and the tangent of the angle, they didn't say find the angle, they want the tangent. The tangent of the angle will be Fy over Fx. Okay, tangent of the angle. So it's gonna be Fy, which is 6 over 8, Fx, which is 8, and which is 0.75. Okay, is this correct? Yes. If they said measure of the angle, then you do shift tan, but they only said tangent, you just do 6 over 8, which is 0.75. A ship is pulled by 2 boats with equal forces. The magnitude of each is 4,000 newtons, and the angle between the forces is maintained at 30 degrees. What is the resultant of these forces? So for this one here, you have to draw it. Okay, let me take this into open board. Imagine the ship is this dot over here. Okay, and one of the forces, let's start, this is F1, where they're both 4,000 newtons. This one's 4,000. Okay, and then they said there's 2 forces, but they're both 4,000, and there's an angle between them which is 30 degrees. So if this is my first force, the second force would be 30 degrees above it. Okay, 30 degrees. Okay, and here 4,000. How do I find the resultant? I have to find the Fy and Fx for each one. Let's call this F1 and let's call this F2. The fx of force 1 would be 4000 cosine 30. And the fy for force 1 would be 4000 sine 30, which is I think 2000. I don't know about I don't know about this one though. For f2, fx2, it's obviously 4000 because it's only acting in the right direction. You can, if you want to prove it, you can do 4000 cosine 0, which is 4000. And for fy2, it's going to be 0. If you want to prove it, you do 4000 sine 0, which is 0. Okay, so if you want to now find the total fx, it would be 4000 cosine 30 plus 4000. And then the total fy would be 2000 plus 0. Okay, so here you're going to get, let's just open the answer key. 7464 and 2000. Okay, 7464 newtons, 2000 newtons. Okay, how do I find the resultant? The resultant force is always radical fx squared plus fy squared. So 7464 squared plus 2000 squared. What do you get? 7727. Okay, you get 7727. Okay, and then what's the angle? They said no, they just wanted the resultant. Okay, what do they want here? They want, oh, also, yeah, when they ask for the resultant, you not only specify the magnitude of the force, you also need to specify the angle and direction, right? Because remember, what are the three characteristics of a force? The direction, the magnitude, and the point of application. So we need the direction of this here. Okay, how do we find the direction? We do shift tan. It's like finding the angle, fy over fx, which is shift tan 2000 over 7464, and you get, they said 15 degrees. I think they said 15. Yeah, 15 degrees. If I were to draw this here, it would be halfway through over here, and we call it Fn. It's the net force. Put the angle 15 degrees, and we put the magnitude of it is 7727 newtons. Okay. A man pulls a rope attached to a box with a force of 80 newtons, making an angle of 60 degrees with upward vertical. Okay, so he made an angle of 60 degrees with upward vertical. Find the horizontal component and vertical component of the force. Okay, since he's making the angle with the vertical, okay, it's gonna look like this. So we said 80 newtons, okay, 80 newtons, and it's gonna be 60 with the vertical, okay, not with the horizontal, with the vertical. And what do we say we do when we have the angle with the vertical? We do cosine for the y and sine for the x. We flip them, right? So now fx here would be 80 sine 60, okay, and fy would be 80 cosine 60, okay. And well, what do you get? They did 90 minus. Okay, I mean that works as well. Okay, but you get 69.2840. Okay, you can do 90 minus, by the way. It's no difference, or you can do sine and cosine. Question 14. What is the magnitude and the direction of the resultants here? This came in our written part, periodic, I remember. Okay, it's like the one we solved up, right? It's the same thing except 53 point. Okay, point. Okay, I'm not gonna solve this. Uh, in the diagram below, list some pairs of action and reaction that may exist between any of the two bodies involved: Earth, inclined surface, horizontal surface, cart, string, block, and pulley. So I'm just gonna pull up the answer key. Okay, the easiest two would obviously be the weight of the car and the Earth pushing back up on the weight. Okay, then the normal force. Okay, and the reaction of the car. Okay, that would be the easiest two. If you want also the weight of this, or sorry, you know what? Yeah, okay, you can do the same for the block here, and then like the pulley would be moving to the left. Okay, the reaction with the pulley be moving to the right. I mean, it's a stupid question. Question 16. State Newton's third law of motion. This Newton's third law is that for every action there's an equal and opposite reaction. Okay. Question 17. What are the perpendicular and tangential components of the force exerted by any surface of? So the perpendicular component is always the normal push, because you always know the normal is perpendicular to the surface, and the tangent is the force of friction. Okay, because يكون عندك ball surface, the tangent force would be the one striking at only one point. Okay, and that would be the friction. In each of the following cases, list the force acting on the body and draw a free body diagram. A bicycle moving at a steady speed. Obviously, oh wait, if it's a steady speed, uh, if it's moving at a steady speed, okay, think of the bike like this. You always have the weight, okay, and then the normal reaction, right? And the biker is putting a force F, okay, and obviously there will be a small f, which is the friction, okay. The length of the friction and the force, they should be the same because they cancel each other out because we're moving at a steady speed. Okay, if it's a steady speed, yani the net force is zero. Okay, so it looks like this. You can swap f and f, it doesn't really matter, just depends on which direction. Okay, part I, a skydiver falling through the air with a parachute. Okay, uh, so there shouldn't be anything pushing the diver down other than the weight. And since we're not really on a surface, we're in the middle of the air, that means that we're not going to have normal. But what's going to be the force reacting to the weight? It's obviously going to be, since we're in the air resistance, okay? You can call it F, I guess. They called it F, but if you have to specify, by the way, what each thing stands for. Like on the side, you have to write F, air resistance, W, weight, okay? An object resting on a slope inclined at an angle to the horizontal. So imagine it like this. You have an inclined plane. Okay, there's an angle here. We have our object over here. Okay, obviously we're gonna have the weight. The weight is always perpendicular. Okay, you don't go to the side. No, it's always perpendicular. I'm sorry. It's always perpendicular to the to the normal. I get no, not to the normal. To the horizontal. Whatever, but the weight always goes down. Okay, the normal is perpendicular to the inclined plane. So the normal isn't gonna be straight up. No, it's gonna be like this. Okay, that's what they're trying to test you on here. And okay, since it's at rest, what's stopping the object from moving down? Akid is gonna be the friction force. Okay, describe the ya Allah. And before we go on to part B, by the way, because you're gonna use this later in chapter 9, depending on how long this recording is, that's probably 5 hours after what I'm saying now. Um, a perpendicular force will do no work, so you're gonna have to have something else to cancel out the weight. Okay, that's why we have the friction to cancel out the weight. The normal kind of just does no work. المهم, describe the reactions to each of the above forces. Okay, I'm gonna open the answer key. The reaction to the normal force is obviously the force. Okay, like here. Oh, they did it for each part. No, no, they didn't. Okay, so the normal first force, always the reaction. The normal is pushing the object up. So obviously the reaction to it would be the object pushing it down. I guess the reaction to N is the normal push exerted by the bicycle on the ground. So it would be the ground pushing the bicycle up. What would be the reaction? Reaction would be the bicycle pushing the ground down. Okay, the normal push exerted by the bicycle on the ground. Okay, the reaction to the friction here, which one? Okay, we're talking about the bicycle still. Obviously, friction would be the pulling force of the ground. It would be the force F friction is the force, it's the pull exerted by the ground on the bicycle. So here it would be the push exerted by the bicycle on the ground. For now, let's not say pull, let's just keep it as push, okay? So friction would be the ground pushing the bicycle, so it would be the horizontal. N was the normal push, but friction is always horizontal, okay? So make sure to specify that. Okay, the reaction to friction is the horizontal push exerted by the bicycle on the ground. Then they said the force F, okay, the force F would be you putting the force on the bicycle, the rider putting the force on the bicycle, so obviously it would be, the force F would be the push of the bicycle on the rider. Okay, then F here for air resistance, okay, it was F is the air pushing the parachutist. Okay, so obviously it would be the force exerted by the parachute on the air. Question 19. What are the steps followed when drawing a free body diagram? I think this comes in the multiple. Okay, draw the object O. Okay, to draw the free body diagram of an object O, use these steps. Draw the object O. Usually it's a point. Okay, represent each force by an arrow in the direction of that force. Next to each known force, put its value if given. So if you know the value, you put it. Represent each unknown force by a letter. You can just call it X, Y, whatever. Write down any given value such as angles and distances. Okay, this comes in the multiple. I think you press select all that apply, whatever. Okay, question 20. A dry ice block with a weight of 2 newtons moves with a constant velocity. Sketch the appearance of its multi-flash photograph and its free body diagram and find the magnitude and direction of the other force involved. Give the full reason for your answer. Okay, I'm gonna give you the answer key. Okay, the other, what was it? Weight. Obviously, the other force. Okay, what is the reaction to the weight? So let's say it is the ice block. We have the weight, which is 2 newtons. Obviously, always you're going to have the normal reaction, right? Okay, what does they say? Find the magnitude and direction. Obviously, if it's 2 newtons down, so it's going to be 2 newtons up. Is this correct? Yeah. So it's always equal to the magnitude of weight, so it's 2 newtons, okay? Then they said the appearance of its multi-flash photograph. This won't come, but since it's moving at a constant velocity, okay, that means the distance between every one will be constant because it's moving at a constant velocity. Okay, uh, that doesn't really any. Question 21. What is the effect of zero net force on an object? If the net force is zero, okay, then it's gonna have constant velocity. صح? When forces are balanced, if it's initially at rest, it will remain at rest, but if it's in motion, it will remain in the constant velocity. So same speed, same direction. Okay. So if it's not moving, it's like at rest. If a book is at rest on a table, and there's no force being applied on it, if the net force is zero, then obviously the book will remain at rest. But if I'm moving, I'm driving a bike or driving a car, and the net force on the car is zero, that means I'll remain in the same direction and same speed. So in other words, you can just say same velocity. How is the constant net force acting on an object related to its acceleration? Okay, how do the constant net force, they're directly proportional. Because remember, okay, for now, F equals ma. Okay, so the force and the acceleration are directly proportional. So just to differentiate between these two, uh, when the net force is zero, okay, then the object won't be adding any force. So if it's gonna stick to the velocity, it's not gonna cause a change. Remember, an object that is not acted by any external force will remain in the state it is. This is the law of inertia, right? Okay, so if an object has zero net force, then it's gonna stay in its state. But if the net force is constant and it was 6, that means I'm applying 6 newtons of force every, I don't know, but I'm applying a force, so I'm pushing it, so hence it will accelerate. Okay, don't get mixed up if is a constant. Some people if بيشوفوا constant net force, they put zero acceleration. لا. Okay, and always remember also F equals ma, so they're directly proportional, the acceleration and the force. Question. Oh my god. Oh, my eyes, my eyes, my eyes, my eyes. A trolley T1 runs at a constant speed down a friction compensated slope, so there's no friction. When a force F equals 12 acts on the trolley, okay, the trolley has a constant acceleration of 6 meters per second. Using the equation F equals ma, find its mass. Okay, you just divide, right? Force equals, so 12 equals the mass times the acceleration 6. Obviously, mass will be 2. 12 divided by 6. Okay, mass will be 2 kilograms. Where am I now? What they asked us to draw? They didn't ask us to draw, no? They didn't ask us to draw. Okay. Okay, a trolley T2 runs at a constant speed down the same friction compensated slope. When the same force F equals 12, the trolley has a constant acceleration of 3. Find its mass. 12 divided by 3, 4 kilograms. Yes. Okay, the trolley T1 and T2 are placed one on top of each other and are adjusted to run at a constant speed down at a friction compensated slope. When the same force F equals 12 acts on the combined trolley parallel to the slope, the combined trolley has an acceleration of 2 meters per second squared. From this information only, find the mass M3 of the combined trolley. Is it just 6 kilograms? Okay, yeah, 12 divided by 2. What are these questions? Okay, express mass M in terms. Okay, I forgot I have to explain. Okay, F equals ma. So the force is 12. We don't know the mass. Acceleration is 2. I don't want to write F equals ma for 12 equals mass times 2. So mass is 6 kilograms. Okay, don't forget the unit. Express mass M in terms of the magnitude of force F and acceleration a. M equals F over a, right? Because F equals ma, so you just take a to the other side, it's F over a. Okay, a car of mass 800 kilograms traveling at 40 meters per second stops after traveling a distance of 40 meters. Calculate the average force applied by the brakes. Okay, we know force equals mass times acceleration. For this one, we have the mass, okay, and well, we want the force. So we know that force equals mass times acceleration, and we don't have the acceleration, but we have things that could lead us to the acceleration. Okay, so it was at 40 meters per second, and then it stops. So our initial velocity is 40, and then it stops, so the final velocity is 0. Okay, and the distance x is 40. Okay, which one has, and we want acceleration. Can we find acceleration? We have u, v, x, and a. Remember that v squared minus u squared equals 2ax. Let me add this to our list of formulas, by the way. And go previous, next, previous, next. Oh, here. Okay, we can put it over here. This is chapter 2. Okay, then here we want chapter 3. Okay, we have F equals ma, right? And we also have Fx equals F cosine alpha, and Fy equals F sine alpha. This is when alpha is with horizontal. Okay, and then the magnitude of the force, net force, is radical Fx squared plus Fy squared. And then the angle is always shift tan Fy over Fx. Okay. Okay. That's it for chapter 3, I think. Yeah. Okay. So here we want to use v squared minus u squared equals 2ax. The final velocity, okay, is 0. So 0 squared minus u squared, so minus 40 squared equals 2 times a times x, which is 40. So you get minus 40 squared. Am I doing this right? Yeah, so minus 40 squared would be minus 1600. Okay, 16, yeah, yeah, 1600 equals 80a, and then a would be negative negative 20 meters per second squared. So we can go back here to F equals ma, and we can substitute a with negative 20 meters per second squared. So F equals the mass 800 times negative 20 equals negative 1600. Okay, is this correct? Oh wait, did I do it wrong? Mass times acceleration. 16, no, it's 3 zeros, sorry, 16,000 newtons. Okay, uh they said 16,000 newtons in the opposite direction. You could just say negative 16,000 newtons. It doesn't matter, but if you want, you could just say 16,000 newtons the opposite, because it's negative, we say opposite direction. Okay, a car of mass 500 kilograms is moving along a horizontal road at 36 kilometers per hour, okay, which is 10 meters per second. Okay, the driver stops the car in 2 seconds by applying the brakes. Assume that the brake is a constant force, so the motion is uniform. So I don't know what UVRM is. I think they should write for UARM, because if it's a constant force, then it's a constant acceleration, so it's UARM. Okay, draw a free body diagram of the car. So we can say this is the car. Okay, we have the weight acting downwards. Okay, and the magnitude of the weight will be 5,000. Okay, why? Because W equals mg. Okay, we're gonna add that to the list of formulae. Okay, W equals mg. Okay, uh, then we have obviously the normal force. Okay, which is should be 5,000 newtons. Okay, and then we have the force it's applying, right? F, the car, and obviously the friction force, right? Okay, if it's moving at a constant acceleration, so it's not balanced. Okay, is this correct? Huh, why is there no force? Ah, they're talking about stopping the car. Okay. Mm. So if he's stopping the car, yeah, there's only a friction force. He's not applying the force forward, he's applying the force backward, right? Okay, so we drew the free body diagram. It's like this. You didn't have to calculate the weight or the normal. They just wanted you to draw. Okay, in what distance does the car stop? Okay, so here, in what distance does the car stop? Okay, it's UARM. Okay, which of the UARM formulas gives me distance, but we don't have acceleration anywhere here. We have the initial velocity, okay, and we're gonna use 10 because we were using seconds. Okay, we have the initial velocity and we have the final velocity, which is obviously 0. V final equals 0 because we applied the brakes. Okay, so we have final and initial velocity, we have the time. So whenever you want to find the distance when you don't have the acceleration UARM, you use only one formula, and that is u plus v over 2 times t. Okay, x equals. Okay, so it's gonna be the initial, which is 10, plus the final, which is 0, over 2 times 2. And you're gonna get 20, no, 10 meters. Okay, so the distance will be 10 meters. What is the acceleration of the car? Okay, for acceleration, it's very easy. We can just do velocity final minus velocity initial over the time. Pay attention to use meters per second and not the kilometers per hour. Okay, so our final velocity is 0 because we did the brakes. We stopped. Our initial velocity is 10, and the time is 2. You get negative 5 meters per second. Okay, squared. What is the magnitude of the force friction between the car and the road? Okay, this will be F equals ma. So we found the mass, we have the mass, and we found the acceleration. So it should just be 500 times negative 5, which is negative 2,500 newtons, if I'm not wrong. They wanted magnitude. Yeah, magnitude, just make it positive. Okay, so 2,500. Okay, using the same value for F found in part D, determine the distance of stopping if the car is initially traveling at 20 meters per second. So here, if we're saying we're using the same force, and obviously the mass is staying the same, so the acceleration is still negative 5 meters per second per second. Okay, we want to determine the distance. Okay, we have the acceleration. Okay, we have the velocity, the initial velocity, and we have the final velocity, which is obviously zero to break. Yeah, and we want x. Which one has it is initial velocity u? We have velocity final, which is zero. Okay, we have velocity final. We have u. Uh, we have a. Can we find x? Yes, we know that v squared, v final squared minus u squared equals 2ax. V squared final squared is 0 squared because we stopped. Minus u squared. Why did I put equal? Minus u squared, so minus the initial velocity squared, so minus 20 squared equals 2ax, so 2 times negative 5 times x, so negative 10x equals negative 400. Okay, so x equals 440. Is it 40 meters? Yes. Okay, so here for part E, for part F, you have to look at the answers you got for part B and for part E. Okay, I'm gonna erase this. For part B, we said that it was stopping from 10 meters per second. Okay, but now we said 20 meters per second. For part B, our answer was, I think, 10. Where is it? 10. And for part E, it was 40. So when we doubled this multiplied by 4. So when this is multiplied by 2, this multiplied by 4. So we found out that what's it called? What's it called? The stopping distance is proportional. Yeah, we found out that this is proportional to the square of the speed. So if this multiplied by 2, this multiplies by the square of the speed. Okay, we got it from v squared minus u squared equals 2ax. And we always know that this is 0. So if you multiply this by 2, this squares becomes 4. Okay, if you multiply this by 3, you multiply it's gonna square. Okay, because you're squaring u. Okay, that's why you can just say yani the change in the stopping distance is proportional to the square of the change in the speed. Okay, that's it. Okay, question 27, mass 800. When you want, and then they give you velocity and they give you stops in 7 seconds. Okay, and then they ask you to find force. Obviously, F equals ma. Whenever you want the acceleration and you're talking about stopping in a certain amount of time, use the formula v squared minus u squared equals 2ax. V squared is obviously 0 because it's the final velocity we stopped, minus u squared is 28. Sorry, wrong equation. Acceleration equals delta v over t. Use this, okay? Because they gave you the change in velocity and they gave you the time. So you can directly apply delta v, velocity final, which is 0 since we stopped, minus the initial velocity 28, over the time taken, which is 7. So it's going to be minus 4 meters per second per second. Okay? That's the acceleration. Okay? So if you were to do force equals mass times acceleration, the mass would be 800 times minus 4, which is minus 3,200. Okay? Is that correct? 3,200 newtons. Oh yeah, you have to mention the unit. Opposite to the direction of motion. And I don't know why they're okay. I guess since they said it more than once now, if you get a negative force, just say opposite to the direction of the motion. Okay. Then part B, what would the net force be if the car is moving uniformly? If it's moving uniformly and the velocity is constant, and we said if it's a constant velocity, then the force is 0. Okay, according to Newton's first law of motion, if the car moves uniformly, then the net force is 0. Question 28. In each of the following cases state whether the gravitational force causes an acceleration or not. A stone dropping down a well, I think so, yeah, obviously. A girl diving from a height, I think so. A boy sliding on a horizontal, okay, I don't think so. A man high jumping over a bar. I'm not sure about those answers. Okay, yes, yes, no, yeah. Okay, well, he's still jumping, so it causes him to slow down, then speeding up down. Okay, yeah. Whenever you're going, when you're changing up and down, then there will be some sort of gravitational force. Okay, a 3 kilogram apple is placed on. Okay, what is the weight? We said W equals mg, right? So 3 times 9.8 and you get 29.4 newtons. Please specify the unit. A body is free falling near the surface of the earth. What can be said about the body's acceleration? If it's free falling, that means you're neglecting friction. Okay, and if it's Okay, whenever you don't have friction, that means you'll always have a constant net force, hence you're gonna have a constant acceleration. Okay, what is the only force? Obviously, it's just gonna be the weight. Yeah. Okay, 3.15 is not required, so we're gonna skip this. Okay, experiments, we do not care about this. Okay, although Jupiter is more than 300 times as massive as Earth, a body would barely weigh 3 times as much on the surface of Jupiter as it would on the surface of the Earth, and not 300 times. Explain why. So this brings us to our next formula. Okay, F equals G times M1 times M2 over R squared. Okay, G is the gravitational constant, which should be given. It's like 6.67 times 10 to the power of negative 11 or something like this. I don't know. For basically, you just have to say, in the answer key, they say it's a lot of yep. Okay, I don't think this is gonna come, uh, but they substituted. Question 33. When you stand on a scale balance, what does the scale read? Obviously, it's gonna read your weight. It's uh, the force given by you, the weight. Does the reading vary as you move to a higher altitude? Yes, it does, because we know that W equals mg, right? Okay, well, the reads one's weight, but it's calibrated to display the mass taking into the. Okay, so well, enter when you stand on a scale. Okay, the actual reading it gets is the weight. Okay, but it shows you the mass because that's just how it's programmed. Okay, the scale has a higher reading when you go at a higher altitude because uh, it's gonna be a higher reading as you go higher because it measures your scale. Okay, it measures your weight, and we know that it equals the weight divided by g. As you go higher in altitude, okay, as altitude increases, okay, g decreases. Thus, your mass, sorry, the reading will be any higher. And by the way, if you're wondering why, it's because we said here that the scale is calibrated to display the mass, and the mass will increase. Okay, whatever. Question 34. What is the expression of the gravitational force F between the two objects of masses m1 and m2 separated by a distance r? It's the one we wrote here. F equals g m1 m2 over r squared. Is it here? G m1 m2 over r squared. Okay, for section 3.17, draw a free body diagram of the following objects. A satellite of the Earth, a man inside the spaceship, a book inside the spaceship. Why does the book inside the spaceship seem weightless to the mind? Why all of them have the same diagram is because in outside of outside of Earth's atmosphere, there's only one force acting, and that would be the weight. Then they say, why does it seem weightless? Okay, because both the man and the book are accelerating towards the center of the Earth at the same rate. Okay, all of them, since they're only acted upon the force of weight, that means they're only acted upon that acceleration, the gravitation acceleration. And since they're all acted upon that pull to the Earth, which is the weight, then you feel weightless. Okay. 36. Define terminal velocity. Okay, terminal velocity is just the maximum velocity an object can attain. Okay, terminal velocity is the constant velocity. It's a constant. Okay, it's reaches when the when air resistance equal to the weight. Okay, when the magnitude of the air resistance is equal to the weight. So, like, think about it like this. New page. You would have an object weight 6 newtons, okay, and the air resistance at this instant would be 4 newtons, okay. Eventually, the air resistance will begin to increase. Here, it will be 7 meters per second. But here, when the weight equals 6 newtons and the air resistance equals 6 newtons as well, then the velocity becomes constant, and now it becomes 6 meters per second. So my terminal velocity is 6 meters per second. So when the magnitude of the weight is equal to the magnitude of the air resistance. Okay. Explain why the terminal speed of a parachuter is lower than when the parachute lower when the parachute opens than when it does not open. Obviously, when the parachute opens, you have more air resistance, so there's going to be a lower terminal velocity. So due to its concave shape and its large surface area of the parachute, the air resistance on the parachute man system is larger than the air resistance than when there's no parachute, right? Then when comparing the parachute to the man, obviously the parachute would contain more air resistance and the man would have less air resistance. So obviously the terminal velocity of just the man alone would be higher than when the parachute is open. And then think about it. When you enter, you're free falling, you don't open your parachute, obviously you're gonna accelerate to a very high velocity. But enter when you have a parachute, it's gonna be a way lower velocity. A parachute is falling down with a constant velocity. If its combined weight is 700 newtons, what's the magnitude and direction of the force of air resistance on the parachute man system? Since we said it's a constant velocity, معناته he reached his terminal velocity. Okay, if his weight is 700 newtons, then we said it's a terminal velocity, معناته the air resistance would be equal to the magnitude of the weight. It's also going to be 700 newtons, and the direction would be opposite to the weight. Terminal velocity, okay. Okay, so they said draw a free body diagram. Okay, yeah. For the different stages, okay, yeah. So it'll be this, and this, then. Question 38, it always comes. Okay, a parachute is descending vertically as shown below. This will come. I have a feeling it will come. Oh, where'd I go? Okay, describe the motion of the parachutist from the time he opens the parachute until he reaches terminal velocity. Draw the velocity time graph. Okay, I don't know about that, but this describe the motion. It always comes. Remember, they say like order the stages or something like that. Okay, at the time the parachute opens, okay, air resistance starts acting along with his weight. Therefore, the net force acting on him decreases. Why? Because now we have air resistance. Similarly, his acceleration will also decrease. Okay, so step 1, the guy jumps out. Step 2, he opens the parachute and air resistance starts acting on it and the acceleration begins to decrease. Okay, step 3, okay, as he continues falling, the air resistance will increase until it's equal to his weight. Okay, so that's step 3. And then at step 4, okay, this moment, he reaches the terminal velocity, he stops accelerating and he reaches a constant velocity. It's called the terminal velocity. Okay, if they asked you, okay, you'd have to draw it as a curve, okay, because it's not a constant acceleration. Okay, it's يعني هيك. Okay, it's bending due to air resistance. Please make sure it's a curved graph if you do get it. It's a grid. يعني maybe they get it in the written. Okay, and obviously you have to label velocity, meters per second, and time in seconds. You have to label your graph. Okay, and then put identify where the terminal velocity is like this. Okay, make sure. A satellite keeps moving in a circular path. What force keeps the satellite in orbit? Obviously, the weight. And how does this force act? It's perpendicular to the direction of motion. This comes every AMS. This question, this exact one. They ask you to. They don't say how does this force act. You don't like. It's not multiple choice. They give you 4 pictures and you have to choose the one that's perpendicular. State Hooke's law. When does it apply? Okay, Hooke's law is F equals K delta L. You can say X. You can say X or you can say F equals K delta L. Okay, and this is important. You say it applies when the stretching force does not exceed the elastic limit. As long as the string is following its elastic limit, as long as it's not stretched too much, Hooke's law will continue to apply. Okay, question 41. A spring has an, okay, this comes every AMS. Again, original length of 20 centimeters. When a load of 300 grams is applied to the spring, it produces an extension of 50 millimeters without exceeding the elastic limit of the spring. What will its length be when 240 grams is applied? Okay, remember F equals K delta L. Okay, if this comes in the written, solve like this. If it comes in the computer, I'll give you a different way to solve, which is way faster. Okay, you need to find K. K is F divided by delta L. Okay, the force is gonna be the weight. We can just say mass times mg. Okay, the mass is 0.3 kilograms and g is 10. Okay, so it's 3 newtons. Okay, so the force is 3. Delta L will be 50 millimeters. So we need it in meters. So 0.05 meters. From millimeters to meters, divide by 1,000. Okay, 3 divided by 0.05 is 60, I think. 60. So K equals 60. Okay. So now we want the length. Okay, we know that F equals K delta L. How do we find the extension if we have the force and we have the K constant? We just substitute. 240 grams, what's that force? W equals mg. So 0.24 times 10, which is 2.4 newtons. Okay, so the force 2.4 equals K, which is 60 times delta L. Okay, how do we find delta L? We divide by 60. So 2.4 divided by 60, and you get that the elongation is 4. You get in meters, it's going to be 0.04. Okay, meters. This is our elongation. Okay, you can add the 0.04 meters now to our original spring length, which is 20. So 20 centimeters plus 0.04 meters equals 24 centimeters, because 0.04 meters is the same as 4 centimeters. 20 plus 4 is 24 centimeters. Do this in the written, okay? But now after looking at the solution in the course revision, I think you can also do this way if it comes in the written, the one I'm going to give you. Okay, when you're applying 300 grams, okay, when they give you 2 masses and extension, 300 grams gets me, let's keep it in centimeters, okay? 50 millimeters is 5 centimeters. Okay, 240 grams is x centimeters. Cross multiply, you're gonna get x equals 4 centimeters. So this is my elongation, but we want the final length. So we have to add our initial length. 20 plus 4 is 24 centimeters. Okay, you can do this way, I guess. But if they want it in meters, then you have to make this 0.05 meters, and then this is x meters. You're gonna get 0.04, and you have to make 24 centimeters in meters, which is 0.24 meters. Okay. Question 42. A spring is calibrated when it is at rest. It is then taken into a lift and the 1 kilogram mass is suspended from it. As the lift starts moving, the spring reads 12 newtons for a few seconds. Next, it reads 10 newtons, then 8 newtons for a few seconds. Finally, it reads 10 newtons. Okay, so the final reading is 10 newtons. Explain what is happening with the lift, giving quantitative as well as qualitative answers. So I've been doing this question for 15 minutes and I don't know how to do part A, but a spring is calibrated when it's at rest. It's then taken into lift and a 1 kg mass is suspended from it. As the lift starts moving, the spring reads 12 newtons for a few seconds, the next reads 10 newtons, then 8 newtons for a few seconds. Finally, it reads 10 newtons. Explain what's happening with the lift, given quantitative as well as qualitative answers. Look, the solution here, I don't understand it, but I'm going to give you my explanation, which is correct, but I don't understand how they got 2 meters per second. Here's what happens. You have the spring balance, okay? And you attach the 1 kilogram weight, okay? Logically, it should give you 10 newtons because W equals mg, 1 kilogram times 10, because g is 10 newtons. But it's gonna read 10 newtons, okay? So it starts with reading 12 newtons, then 10, then 8, and then finally 10. So if it starts by reading 12 newtons, is because they're in a lift, which is like an elevator. It's because the elevator started going up. And when it's going up, that means this spring is kind of experiencing more of a force which is going up. Okay, that's why it's going to read 12. Then it reads 10. So it stops going up. So it stops now for a second. Then it reads 8 newtons. 8 newtons, and the reading went down. So that means we're going down now. Okay, the elevator is going down, so that means the spring is experiencing a lower force. Finally, it reads 10 newtons. That's when the elevator finally stops and reads the correct reading. Okay. Then I think part B. Okay, part B is easy. Part B and C are easy. If you're inside the lift and then the spring with the mass attached reads 0, is there a reason to worry? Of course there's a reason to worry. Imagine you're in a lift, okay, and you're looking at the spring and it shows 0, okay, and obviously there's a mass there. How the scale measures is it measures the force, the reaction force, okay? If this is putting it down, it measures the force it's putting up. But if it gives you 0, that means there's no force putting it back up. And what does it mean if there's no reaction pulling me back up? That means I'm free falling. That means I'm falling down. Okay? And is there a reason to worry? Obviously there is. Okay? So the reason to worry would be maybe because the elevator isn't functioning properly, or the elevator is free falling, or maybe the cable of the elevator is cut. Can you use a spring balance to measure mass? Of course you can. If yes, how and under what conditions? Okay, under what conditions? It has to be under equilibrium, not under moving up and down in an elevator. No, equilibrium. You're steady. Okay, how? We know that W equals mg. So to measure the mass, we do m equals W divided by g. Question 43. A marble moving to the left with a speed of 0.3 meters per second collides with another marble having its mass and moving to the right with a speed of 0.8 meters per second. The speed of one of the marbles is half. Determine the speed of the other marble. Question 43. We're going to use now momentum. Okay, P equals mv. Okay, and since we're working with collisions, we're not going to use this. We're going to use momentum 1 plus momentum 2 equals momentum 2 prime. Sorry, equals momentum 1 prime plus momentum 2 prime. Okay, so we're going to use the formula m1 v1 plus m2 v2 equals m1 v1 prime plus m2 v2 prime. Okay, take a look here. We have a collision. Marble moving to the left. Let's call moving to the left with a speed of 0.3 meters per second. So we can say the speed of it is negative 0.3 meters per second. Okay, so it collides with another marble having half its mass. Okay, so the mass of the other marble would be half m. Okay, I don't think this question would come. I even asked my physics teacher and he told me it won't come like this, but you're gonna get something similar to it. Okay, but let me continue. I'll show you why later. Why? Okay, and moving to the right, so this marble having half its mass, half m, moves to the right with a speed of 0.8. So plus 0.8 meter per second. The speed of one of the marbles is half. Determine the speed of the other marble. Okay, here you have to use assumptions. Okay, and I don't think they're gonna give us a question where you have to start assuming and going through all cases. Okay, but I'm still gonna solve it just in case. M1 V1 would be the mass 1. We could just call it M. We don't know, right? It's mass 1 times V1, which is negative 0.3, plus mass 2, which we know is half mass 1, right? So half mass 1 times V2, because we're doing M1 V1 plus M2 V2. V2 is 0.8, okay, equals M1 V1 prime. We keep M1 as M1. V1 prime, we're gonna say now it halved, okay? And since it's a collision, let's say you have this moving here and this moving here, okay? If it's a collision and it halves its speed, obviously it's gonna bounce back in the opposite direction. So if it was negative here, it's gonna become half of 0.3, which is 0.15, and it comes positive because it bounced back in the other direction now. Plus M2 V2 prime. Mass 2 again is still half times mass 1, okay? V2 prime, okay, we're trying to find, we don't know what it is. Times half M1 times V2 prime. Okay, let's start. To make this easy, we can cancel M1 everywhere. Okay, so you're gonna get negative 0.3 plus half times 0.8 is 0.4 equals 0.15 half V2 prime. We can just say half is the same as saying 0.5 V2 prime. Okay, negative 0.3 plus 0.4 is 0.1. Okay, equals 0.15 plus 0.5 V2 prime. If you take 0.15 to the other side and subtract, wait, negative, did I do something wrong? So you're gonna get here, if you take 0.15 to the other side, you're gonna get negative 0.05 equals 0.5 V2. Okay, you divide by 0.5, you get V2 is negative 0.1. Okay, but it's important to know that we bounced back. Okay, meters per second. Okay, after the collision, it bounced back. Okay, so here it was moving to the right with a speed of 0. It was 0.8. It collides. Now it moves to the left. Okay, actually no. Sorry. Take the positive value. And I don't know what happened with my working. Uh, the answer is positive 0.1. Here they took different velocity. They kept this one here 0.3. They made it positive, but they made the 0.8. They took it in the negative sense, which makes no sense for me صراحة. حتى يعني same thing. My teacher said the same thing. That's why they won't bring a question like this. Okay. Question 44. Consider a bullet ready to be fired from a rifle. Denote by M and M the masses of the bullet and the rifle respectively. The direction in which the bullet is to be shot is considered as positive. What is the linear momentum of the bullet before it was shot? Okay, you should know P equals mv, and since the velocity of it was 0, okay, that means the momentum was 0. Assuming the bullet is fired with the velocity v, what will its linear momentum be if v equals 100 and m equals 5 grams? P equals mv, right? So if the mass is 5 grams, it has to be in kilograms, so 0.005 kilograms. So 0.005 times the velocity 100, you're gonna get 0.5, what's the unit? Kilogram meters per second. Yeah, so the unit will be 0.5 kilogram meter per second. Question 45, state the principle of conservation of momentum. Okay, just memorize this one. Two or more bodies interact. This came, I remember it coming. Yeah, it comes every time, every exam, and every time we have AMS. So make sure to memorize it in case it does come again in our final. Okay, I really think they're gonna bring it. Okay, when two or more bodies interact, this is the law of conservation of momentum. Okay, when two or more bodies interact, okay, the total momentum remains constant. Okay, so the momentum before equals the momentum after. Okay, so when two or more bodies interact, the momentum remains constant provided no external resultant force is acting on them. Okay, question 46. A car of mass 800 moving at 25 meters per second collides with a small truck of mass 1200 moving in the same direction at 15 meters per second. After collision, they move with the same velocity. So v1 prime equals v2 prime. Find the velocity after collision. Okay, we have to do m1 v1 plus m2 v2 equals m1 v1 prime plus m2 v2 prime. And since they move with the same velocity, we can replace v1 prime and v2 prime. We can just call it v prime. We'll just call it v prime. Okay. Mass 1 is 800, velocity 1 is 25. Okay, mass 2 is 1200, velocity 2 is 15. Okay, equals mass 1 is 800 times v prime plus mass 2 1200 V prime. Okay, can we find V? Yes, we can. 800 times 20. You're gonna get 2000 V prime equals whatever this is. Okay, do it on a calculator. And then divide by 2000. You're gonna get V prime equals. Let's look at the answer. 19 meters per second. Okay, where's my mouse? 19 meters per second. Question 47. A rocket engine exerts an upward force of 5.0 times 10 to the power 4 newtons for 4 seconds. What's the impulse? Okay, impulse is represented by delta P, and delta P is equal to IT. Okay, please make sure you know this. Okay, they always get this question to find the impulse. Okay, FT, sorry, shoot IT. Force times time. FT. The force is 5.0 times 10 to the power 4 times 4. You're gonna get, I don't know, how much do you get? 2 times 10 to the power 5 newtons per second. Okay, actually it's F delta T in case it comes in the written يعني. Okay, F delta T or FT. I don't think they'll deduct, but in case just put F delta T. Okay, a trolley of mass. Let's write that down actually in our formulas. Previous. Okay, delta P equals F delta T or delta P equals M delta V. Okay, a trolley of mass 10 kilograms is subjected to a constant horizontal force 20 newtons for 3 seconds. If the trolley is initially at rest, what will its final velocity be after 3 seconds? So here we actually have the mass and we have velocity, right? And here we have force times time. Force times delta T, right? That's actually delta P, right? And mass times, when I say initially at rest, that means, and they're telling you velocity, they're giving you the initial and the final velocity. So they're actually telling you M delta V. So this is also delta P. So aren't these two equal to each other? Yes, they are. This is gonna come same style of question in the exam. So the force at 20 times the time 3 equals the mass 10 times delta V. And since it's initially at rest, you can just say V. So you get 60 equals 10 V. V equals 6 meter per second. Okay, in a lab, now we're on the top questions. In a lab, an experiment is carried out to determine the relation between the mass of a trolley and the force required to move it through the length of the room in 3 seconds. Okay, so the time is 3 seconds. The measurements are repeated for a series of different forces with the results shown in the table below. Okay, so in 3 seconds. So for a mass of 0.2, we need a force of 0.62. For a mass of 0.4, we need a force of 0.74. Mass of 0.5, 0.8, 1. Okay. On the graph paper below, plot these points and draw the straight line of best fit for your points. Okay, mass. Okay, we're increasing. Let's put the scale as 0.2. Let's put 0.2. Let's put 0.4. 0.6. 0.8. Well, no, they're too close. How do they do it in the solution? They use what scale did they use? 1, 2, 3, 4. Okay, they used 4. Okay, so 1, 2, 3, 4, 0. I'm convinced we don't have the same graph. Is it? I don't know. Okay, 0. Okay, 1, 2, 3, 4, 0 0.4. 1, 2, 3, 1, 2, 3, 4, 0 0.6. 1, 2, 3, 4.8. 1, 2, 3, 4, 1. 1, 2, 3, 4, 1.2. Okay, then graph each one. Force is going to be, it increases to 1.1, so we can just say maybe same scale. We use the same scale for the force. 3, 4, 0 0.2, 2, 4, 0 0.4, 2, 4, 0 0.6, 2, 4, 0 0.8, 2, 4, 1, 2, 4, 1.2. Okay. At 0.2, now we just graph each one. 0.2, 0.62, so like over here. Okay, and then 0.4, 0.74. It's right under 0.8. So this is it's 4 blanks, 0.75, so over here. Okay, 0.5, 0.8. So in the middle here, 0.8. Then 1, 1.1. 1, 1.1. Okay, then they said sketch the line of best fit, so you just draw a line through them. Okay. Okay, part B, they say the graph obtained does not pass through the origin. Find the value of this force corresponding to m equals 0. You'd go to your line you have, so when mass equals 0, okay, and you get 0.5. You just see from your graph, okay, so 0.5 newtons. You go to where is mass equals 0 over here, and you see in your graph 0.5. Fine, if I actually extended my graph, I'll draw a line and extend it just so I show you something like this. See, it passes through, it reaches 0.5. So at mass equals 0, it's at 0.5 kg. Okay, give one reason why the FM graph does not pass through the origin. So for part II, they're saying give one reason why the FM graph does not pass through the origin. The mass, we said, can become 0. When the mass is 0, the force isn't 0 for some reason. Why? Like, okay, think about it like this. When even there's no trolley, there's still some force being pushed. Okay, so that we could just say it's the background force. In the answer key, they called it the air resistance force or the dissipative force. Okay, if this does come in your written, just say it's the air resistance force. Okay, part C, determine the gradient of this graph. I'm not gonna do this. You guys know how to find the slope. Okay, يعني just do x2 minus x1, sorry, y2 minus y1 over x2 minus x1. Okay, let's take these points here. Any 2 points, y2 minus y1 would be 1 minus 0.3, 1.1 minus 0.8 over 1 minus 0.5, 0.5, you get 0.6. Okay, and what does the gradient represent? I think they're going to ask that next. Okay, the gradient in this, by the way, represents acceleration. Because force divided by mass is acceleration. Assume that the trolley starts from rest, calculate the length of the room. So, why they asked us to find the gradient? Because that is the acceleration, which is 0.6, right? They're saying now to calculate the length. So, they want the x, they want the displacement. Okay, we have the time, which is 3 seconds. Yeah, we have the time, which is 3 seconds. Okay, we have the time is 3. Can we find x when you have acceleration time? Yes, x equals half at squared. Since it's starting from rest, u is 0 and x node is obviously 0. So it's going to be half times 0.6 times 9. Is that what they did here? Yeah, 2.7 meters. Okay, question 50. A box is placed on a smooth inclined plane. The two forces acting on the box are its weight, acting vertically downward, and the normal reaction, acting perpendicular to the inclined plane. The magnitude of the weight is 10. So the magnitude of the weight is 10 newtons and the normal reaction is 6 newtons. The angle between the vertical and inclined plane is 53 degrees. Using a scale of 1 centimeter equal 1 newton, make a scale drawing to show the resultant force on the block. Okay, we're gonna just draw this. Oh, whoa. Okay, I'm gonna skip this question, okay? Yeah, okay, we won't get something like this. But this may be, obviously, two scalars would be distance and speed, two vectors would be velocity and displacement. A student wants to measure the spring constant of a spring. To do so, she attaches slotted masses to the free end of a vertical spring and measures its length. She's using G equals 10. The student's data is shown below. Okay, L is 12, 13.5, 15 point, okay, whatever. So, using the student's data to complete the following table relating the extension of the spring to the weight suspended. Okay, when mass equals 0, obviously weight is 0. And what is the extension? 0. صح? Then when the mass is 200, what's the weight? W equals mg, right? And the mass is 0.2 kilograms. It has to be in kilograms. So 0.2 times 2, 2. Okay, what is the delta L? 13.5 minus 12, which is 1.5. Okay, please pay attention. Maybe they put meters for your answer. You have to make it in meters, but see, they kept it centimeter. 500 would be, the weight would be 0.5 times 10, which is 5. Okay, because you have to convert kilograms. Then 15.8, you do minus 12 because it's delta L. You don't minus the one before it. No, you minus the initial one. Okay, which is gonna be 3.8. Then 600, 0.6 times 10 gets me 6, and then 16.5 minus 12 is gonna be 4.5. Okay, plot a graph. Okay, I'm not gonna plot it, but you guys, I'm gonna show you the answer key. Okay, over here, just plot the points. Is there a direct proportionality between the two quantities in question? Justify your answer by referring to the graph. Okay, is there a direct proportionality? To know whether something is directly proportional, you connect them. Okay, you connect the points. Okay, if the points form a straight line, then they're directly proportional. not only does it have to form a straight line, but it has to pass through the origin. And one of our points is 0, 0, right? So does it pass the origin? Yes. Is it a straight line? Yes. So you say yes, yes, it's a straight line passing through the origin. So it is what do you call it? Directly proportional. Use the data to determine the spring constant. The spring constant, we know that the spring constant is always F over delta L, right? K equals F over delta L. So you can just take any 2 points, okay, from here, from our table that we got up here, and divide the force divided by delta L. So 2 divided by 1.5, and you should get 3. Oh, okay, wait. Okay, I don't know how I divided 2 by 1.5 and got 3. But 2 divided by 1.5 is 1.3. So the spring constant K would be 1.3. Yeah, 1.3. Can the spring constant identified be used to predict the extension of a spring when 1 kilogram of load is attached to it? Justify answer. I should be no. Yeah, no. Why? Because we know when it comes to Hooke's law, okay, you can measure as long as it fits. As long as it fits the spring, as long as the spring isn't broken, okay. And if you use 1 kilogram, okay, 1 kilogram, that's a lot of mass, okay. So there's a limit to the direct proportionality in Hooke's law, okay. So you can just say there's a limit to how far the spring can extend. A piece of paper is placed on a turntable whose radius is 30 centimeters. The turntable initially at rest begins rotating at an increasing rate. The speed of rotation it increases until the piece of paper slips off the turntable. This happens when the turntable starts making 10 revolutions in 2 seconds. Why does the particle slip? So in the answer key, they say friction is too low to maintain centripetal acceleration. We did not take centripetal acceleration. You're going to take it in grade 11. So we can just skip this question. Okay, 53. A student has 2 identical springs, each of unknown constant K. He conducts 2 experiments. In the first, he studies the extension of 1 spring by known weights. In the second, he studies the extension of 2 springs connected in parallel as shown in the diagram below. Okay, experiment 1, experiment 2. The force extension graphs obtained in the experiments are shown below. He graphed them. Okay, explain how the slope of the graph helps find the spring constant in each experiment. Okay, we know that K is F over delta L. Okay, so what do they say here? Yeah, okay. So K is F over delta L. And isn't that our slope of this graph? It is force divided by delta L. Okay, so you can just say K equals F over delta L, which is the slope of the graph. That's it. I mean, you don't really have to say anything. Yeah, and that's the slope of the graph. Okay, part B, I think they say use the graph to determine the spring constant in experiment 1. How do you find, you don't take the curved part, okay? Take the straight part. Let's take this 4. Let's take this 8. At 4, it's 4 millimeters. It's 1 Newton. And then 8 millimeters, it's 2 newtons. We know K equals F over delta L. Okay, the force, I don't know why I'm using formula for calculating the slope. If it's slope, sorry, you do a rise over run. Y2 minus y1 over x2 minus x1. Y2 minus y1 is 2 minus 1 over x2 minus x1, 8 minus 4. But you're going to get 2 over 4. But this is 1 over 4. But this is millimeters, and we know that it has to be in meters. So it's going to be, to divide from millimeters to meters, you divide by 1000. It will be 0.004. And you get 250 as your spring constant. Okay, then part B, they say experiment, use the graph to determine the spring constant of the combination of springs in experiment 2. Okay, same thing. Let's take 0.42, 4 millimeter, 2 newtons, and the 0.6 millimeters, 3 newtons. Okay, rise over run. So 3 minus 2 over 6 minus 4. You get 1 over 2. But this has to be in meters, so it's going to be 1 over 0.002. You're going to get 500, I think. Yeah. Okay, then part D, I saw a sigma. I don't know if we're going to use that. Deduce the equation for the spring constant of the system of identical springs connected in parallel. Okay, so here we got 250 for experiment 1. But when he used 2 of the same spring, it became 500. Okay, so over here, it's just the same spring twice. So obviously the spring constant would double, right? So deduce the equation, it would be K1 plus K2. Or what they said is sigma Kn, I think something like that. What did they say? Sigma Ki or N, okay. But you have to say K equals, huh? K equals. So this just means you add up each constant for each spring to get the total constant. Okay. Explain why each graph bends for extensions of 10 millimeters or higher. You could just say it becomes inelastic. It loses its elasticity. We're done chapter 3. Now chapter 4, moments. Okay, chapter 4. Let's go to our equations. Previous. Okay. So we had these for chapter 2. These were chapter 3. These are gonna be chapter. Oh, these are gonna be chapter 4. Moment. The moment is expressed as m, and it's equal to f times d perpendicular. Okay. What is the moment of force? The moment of force is the turning effect of the force. Okay, it's the measure of the turning effect of the force. That is the force at the moment. 4.2. Using a spring balance calibrated in newtons, apply a force F at the handle of the door perpendicular to the plane of the door. Then apply a smaller force F also at the handle and perpendicular to the plane of the door. Which force has a larger turning effect? Okay, obviously force F, since it has a larger magnitude. Okay, using the Newton meter, applying a force F at the handle of the door perpendicular to the plane of the door. Then applying equal force F prime, also perpendicular to the plane of the door, but a point closer to the hinge or axis of rotation O. Which force has a larger turning effect? Obviously force F, because it's farther away from the hinge. Okay, so if I had a box and the hinge was over here, okay, and I applied a force here, 2 newtons, and I applied a force here, also 2 newtons. Which one will have a larger turning effect? It will be the one furthest away from the hinge. So let me go back here. Okay, so since force F is further away from the hinge, then it will provide a larger turning effect. What is the magnitude of the moment of a force around a pivot? It's F times D, where F is the magnitude of the force and D is the perpendicular distance from the line of action to the force. Okay, find the moment of each of the forces, first about point A and then about point B. Okay, about point A, let's start with F1. The first thing you check is whether or not the direction of the force intersects with the turning point. And F1, it intersects. And we said if it intersects, the moment of F1 is 0, because it intersects with the point of application of, because it intersects with the point of rotation. How about F2? Let's draw a line. Does it intersect? Yes, it does. So moment of F2 is also 0. Okay, هلا باقي F2 و F3 و F4. F3 doesn't intersect, okay, but so we can find this moment. So the moment of F3 will be the magnitude of F3, okay, which is 30, okay, times the distance perpendicular. Is it 5? No, we want the perpendicular distance. So you draw the line of action of the force, and you draw the line of action of the hinge, and see where is it perpendicular. It's perpendicular here. How far is that? It's 3 meters. So 30 times 3 equals 90. Also, it would be useful to say F1 around A, F2 around A, and F3 around A, just to specify in case it comes in written. The unit of moment is Newton meter. Okay, how about the moment of F4 around A? It equals the force of F4. F4 is going downwards, okay? It's clockwise. And we know clockwise is negative. So it's negative 10 times the distance, which is 7. This is perpendicular because this is like this, and then this is like this, and they're perpendicular over here, so it's 7. So negative 10 times 7 equals negative 70 Newton meter. But I'm not sure if they wanted negative, did they? Did they ask for magnitude? No. Okay, it should be negative 70 because it's going clockwise. But obviously here they didn't care. I don't know why. Okay, so we're done here. Now we want to check around B, right? Around B. Let's see moment of F1 around B now. Moment of F1 around B. F1, does it intersect with B? No, right? It doesn't intersect with B. So let's see, moment of F1 is going clockwise as well, because it's going like this. Okay, so it's going to be negative 15 times the distance between it and B. Okay, you can draw the line of action here. You can draw the line of action of F1 and draw the line of action of B. They're perpendicular here. So I want the distance from here to B. Not from here to A. No, I want distance from here to B, right? Because we're going around B. Can I find this distance? It's a right triangle with hypotenuse 5 and base 3. Can I find how much this is? 3 squared plus x squared equals 5 squared. You're going to get x is 4. So this over here is 4. Okay? So the distance is 4. Okay? 4. Negative 60 Newton meter. How about F2 around B? F2 around B. It's going to be, it's going again clockwise for negative 20 times the distance, which is obviously 5. So negative 100 Newton meter. Again, I don't know why they kept it positive in the answer key. Moment of F3. F3 coincides, the line of action of F3 coincides with the turning point. So it's going to be 0. Moment of F3 around B is 0. How about moment of F4 around B? F4 is going clockwise. It's going to be negative 10 times the distance between them, which is 2. Is negative 20 Newton meter. Okay, let's see here. Is it all correct? Yes, but I don't know why. Again, they kept it positive. Question 5. Consider the following canvas ABCD. Determine the magnitude of the moment, magnitude, so here it doesn't matter if it's positive or negative, of the force F around point D. Okay, we want the perpendicular distance, right? So the moment is going to be the force times the perpendicular. Okay, the force is going to be 4. Okay, the distance here, okay, find the perpendicular distance. Draw the line of action, draw the line of action. Where are they perpendicular? They're perpendicular here. So find the distance from this point to D, it's 60 centimeters. But if you put 60, you're gonna get it wrong. Why? Because the distance must be in meters. So you put 0.6 and you get 2.4 Newton meter. That's why did I put M? Newton meter. Is it correct? Yes. Okay. Please make sure to keep it in meters. What is the direction of the torques? Okay, this came, I remember in the AMS. What is the direction of the torques produced by the forces acting on the spanner below? What do you mean direction? Whether it's clockwise or anti-clockwise. Okay, if it's over here, obviously this is gonna push clockwise. This is gonna push clockwise as well. Okay, this is gonna push clockwise. So 1, 2, and 3 are clockwise. 5 is gonna go anti-clockwise, right? 5 is anti-clockwise. Or some people say counterclockwise, but I prefer to say anti-clockwise. If it comes typing, say anti-clockwise. 4 will be 0 because the line of action of 4 intersects with the point of rotation. So moment of 4, no moment. Is this correct? 1, 2, and 3 are clockwise. M1, M2, and yeah. So that if it's clockwise, say it's negative, and if it's anti-clockwise, say it's positive. And then here it's 0. Okay. Force 4 has 0 moment, and counterclockwise, so it's positive. Okay. Question 7. In the following cases, the axis of rotation through O is normal to the page. Okay, so they're basically telling us it's perpendicular. Determine the magnitude and direction of the moment vector, magnitude and direction of the moment vector of the force in each of the cases. So it's going around O. The distance between them is 2 meters, and the force is 3. Is this going to go clockwise or counterclockwise? So use the way I taught you, is to determine the shortest path, like this, or go around all the way like this. Obviously, the red path is shortest, and the red path is going counterclockwise, so it's positive. Okay, so it's going to be positive 3 times 2 equals 6 Newton meter. Okay, here, determine the shortest path from here to here, or go all the way around. Obviously, the red path is the shortest, and the red path is going like this, which is counterclockwise, which is negative. So negative 2 times 2 equals negative 4 Newton meter. Is this correct? Where am I? Negative 4 Newton meter. Okay. In the case below, the axis of rotation O is normal to the page. What is the direction of the moment F? Let's see, it's gonna go like this, right? Obviously, if you drew it the other way around, it would be longer. So it's gonna go like this, which is negative because it's clockwise. Okay, so we say it's clockwise, it's negative. Okay, it's directed. They want the direction. Direction doesn't mean clockwise or counterclockwise or positive or negative. Direction means in or out. Okay, since it's going clockwise, okay, it's in. Always remember, clockwise is in, counterclockwise or anti-clockwise is out. Okay, because when you're working with a screw and you rotate it clockwise, it goes inside the screw hole. But when you rotate it anti-clockwise, it's going to go out of the screw hole. Okay, now question 9, determine the magnitude and direction of the resultant moments. When you have two moments, all you have to do, just add them. Okay, so in this case, we're going like this, right? Which is counterclockwise, which is positive, and the same goes for the second force. So let's call the moment of F1 is going to be 3 times 2, which is 6 Newton meters. And then the moment of F2 is 2 times 3. Please don't put 2 times 1. And I don't know what to tell you if you put 2 times 1. The distance is 3 meters. So 6 Newton meter. And then you add them up. They're both positive, positive. So it becomes 12 Newton meter. They said direction. Since it's counterclockwise, you say out of the page. Is that correct? 12 Newton meter, counterclockwise, out of the page. Whatever. Here, O is over here. So it's going to be the shortest path. Is going to be downwards like this. And that's clockwise. So it's negative. So it's going to be negative 2 times 2, right? For the first moment. Moment 1 is negative 2 times 2. Then moment 2 will be, this is going to go like this, which is also clockwise. So it's negative because it's going like this, yeah? This is clockwise. Okay? Let me erase it so you can see better. From here to here, it would be going clockwise, which is negative. Moment 2 is negative 1 times 1 is negative 1 Newton meter. Here it's negative 4 Newton meter. So the resultant, add negative 4 and negative 1, negative 5 Newton meter. So you could just say 5 Newton meter clockwise direction. Whenever they give you two blanks and they ask you to find the moment, you put one blank for the value and the other blank for the direction, clockwise or anti-clockwise or counterclockwise. What are the characteristics of the forces that form a couple? They're same magnitude and parallel, right? Equal magnitude, parallel lines, and are oppositely directed. Yeah. So whenever you have something like this, you'd have one here. Okay. So I don't know. This would be your point here. Your couple would be here, 1 meter. Then the other couple would be like this, 1 meter. 50 Newton, 50 Newton. Okay, they're parallel to each other. They're in opposite directions and they're at equal magnitudes. They're equal magnitudes. So question 11. In the figure below, the ratio. Oh, see, I think they get this. In the figure below, the ratio of the radius of the outer circle to that of the inner circle is 5 over 2. So r over small r is 5 over 2. Compute the magnitude F for each of the two forces acting on the outer circle so that the net moment of the two couples is 0. Before continuing here, I'm going to give you the equation for the moment of a couple, which is Fd. Okay, just Fd. So let's see here. They're saying that the net moment is 0. So sigma m is 0. Why I'm starting to use this now? Because we're going to use it a lot for the balancing, okay, on the stick and stuff. Okay, here, what is the moment of this couple? 200, 200. Okay, it's Fd. So the moment of couple 1, let's say C1, is 200 times the distance. The distance between them, would be 2r, because the radius 2 times the radius. And the moment of the second couple would be the force. We don't know it, right? Let's just call it F times the distance between them, which is 2 times big R. صح? So we want the net moment of the couples to be 0. So 200 times 2R, sorry, small r, why am I using big R? Should be equal to F times 2R. To make it easier, let's divide by 2 on both sides. Okay, you're gonna get 200 times R equals F times R. Some people might ask, why didn't you divide 200 by 2 as well? Because you were multiplying. When you're multiplying two numbers, you can only choose to divide one of the numbers. Okay, and I want to get rid of the coefficient of R. That's why. Okay. Now here we're faced here. It's important to note in the question they said the radius of the outer circle over the inner circle is 5 over 2. So they told us R over R is 5 over 2. So can I somehow manipulate this equation so I have R over R? Yes, I can. I can divide by r over here and take the f over here. So if I take the f over here, I'm going to get 200 over f equals, if I take r over here, r over r. We know r over r is 5 over 2. So I'm going to get 200 over f equals 5 over 2. Can I just cross multiply? Yes, I can. And you should get f equals 80 newtons. Is it 80 newtons? Yes, 80 newtons. Okay, you're going to get f equals 80 newtons. Question 12. Consider a meter stick of negligible weight. We apply on both extremities of the meter a downward force of 10 newtons, and a 3 kilogram mass is placed at O. Where should a single force F be applied in order to balance the stick? Let's take this into a blank page. Okay, so we're gonna draw the meter stick like this, and at the extremities we have downward force. Always draw. Step 1 is always to draw your forces. Like I always tell you, draw your forces. 10 newtons. Okay, I had to go. I don't know whether I read the question or not. Consider a meter stick of negligible weight. We apply 10 newtons on both extremities, and a 3 kilogram mass is placed at O. Where should the single force F be applied in order to balance the stick? Look, when they say it's placed at O, I'm not sure yet, but I think O means it's the center of the stick. So if we were to take this over here, O would be here at the center. Okay, 3 kilogram mass, that means the force is 30, because 3 times W equal mg, 3 times 10. Okay, since it's the center, this is going to be 0.5 meters. This is going to be 0.5 meters. Okay, where should a single force F be applied in order to balance the stick? We know that there's a force F going upwards, which is 50 newtons. Why 50? Because it's equal to the sum of all of these forces, all right, to cancel it out. And we know that when solving these types of questions, sigma m equals 0. So let's calculate the moments. Always take any point as your moments, one of the extremities. It would be easier to take anyone, I don't care. Let's take this one here, A, as our point of moment. Let's calculate the moment of F4 around A. Moment of F4 around A. It's going to be 0, because the line of action of F4 intersects with A, right? So it's 0. How about the moment of F3 around A? It's going to be going like this, right? So it's going to be counterclockwise. So it's going to be 10 times 1. FD, right? Force 10 times the distance, which is a meter. So 1. So which is 10. How about the moment of F2? This is F2 over here. The moment of F2 around A. The moment of F2 around A is going like this, right? 30 times 0.5, because that's the center. You get you get 15. 15 meters. Sorry, 15 Newton meter. Inside unit for now. Okay, then moment of, we'll call this F1. We know it's a distance x away from A. We want to know how far we put it. So the moment of F1 around A is negative 50, because it's going clockwise, right? Negative 50 times x. So negative 50x. And we know that sigma m equals 0. So if we add all of this up, we get 0. So 10 plus 15 minus 50x equals 0. So you get 25 minus 50x equals 0. You get x equals 25 over 50, which is 0.5. So x is 0.5 meters. So doesn't that mean our 50 newtons should also be placed above the center? Yes, it should. Okay, that's how the answer key goes. But the answer key is kind of weird. I don't understand the answer key. Yeah, just put it above F. They said F should act at the center. Okay. Yeah. Okay, now for question 13. Given the meter stick, again, meter stick, negligible mass, find the single force that will balance the stick and the resultant of the two downward puts on the stick. Okay, so we have 2 kgs and 3 kgs. So here's 2 kgs, so obviously the force will be 20 newtons. Okay, and here it will be 30 newtons. Okay, force downwards, force downwards. Okay, what is the single force that will balance the stick? Obviously, part A will be 50 newtons. Okay, where do I put this force now, right? We need to find out where to put this force to balance it. Remember, sigma m equals 0. Sigma m equals 0. So let's call this force F2, F3, and there's an F1. We don't know the distance of it, x, right? So let's find the moment of F1. Okay, we know F1 would be 50 newtons, right? Because it's 20 and 30 newtons added up, it's 50 newtons. What's the moment of it going to be? You have to always start by taking a point of moment. You can take either F2 or F3. I would rather take F3. I don't know why. It's whatever you want. It doesn't really make a difference. Okay. The moment of F1 around, let's call this point A. The moment of F1 around point A would be, it's going clockwise, so it would be minus 50 times the distance x, right? Okay, the moment of F2 around A would be, it's going counterclockwise, so it's gonna be 30 times 1, because it's a meter stick. The distance is 1 meter. They said meter stick. Then the moment of F3 around A is obviously 0, because the point of action of the force, the line of action of the force intersects with A. Okay, now we know sigma m equals 0, and if you add them all up, you're gonna get 0. So negative 50 plus 30, sorry, negative 50x plus 30 equals 0. So I'm gonna get x equals 0.6 meters. Okay, so 0.6 meters from where, right? 0.6 meters from the place, from the point you took as your point of moment, and we took point A as our point of moment. So F1 should be applied 0.6 meters to the left of A, or 60 centimeters away from point A, or 60 centimeters away from force 2, whatever. So you're gonna get, they used 0.4 meters because they took the F2 as their center of the point of moment. Okay, it doesn't matter. Your answer also would be correct if you put 0.6 meters. Okay, because they didn't specify from where. Now the center of gravity. Okay, so for the center of gravity, we have a new formula. Okay, let's go back to our formula. Weight 1 over weight 2. You know, I'm not going to use it. It's confusing. It would be better to say weight of A over weight of B. Let's call the center of gravity G. Okay? No. Let's call the center of gravity C. Okay? Equals the distance between B and the center of gravity over the distance between A and the center of gravity. Okay, this is the formula. Weight A over weight B equals BC over AC. Okay, the way they say it is W1 over W2 equals GG2 over GG1. Okay, so this is confusing because there's like a lot of G's and I don't want to use that. Okay, so let's use this for now. Okay, or let's call this center of gravity G. BG over AG. Okay, it's cost. So this was the answer key. Okay, so here we have centers of gravity A, B, and C form an equilateral triangle of side 8 centimeters. I don't think this will compass, we still gotta solve it. Okay, so imagine this is an equilateral triangle. Okay, A, B, C, 8 centimeters, 8 centimeters, 8 centimeters. Okay, find the center of gravity S, knowing that the mass of A is 0.3 kilograms, so we're gonna call this 3 newtons because the weight, I want the weight. W equals mg, so mass times gravity, which is 0.3 times 10, then 0.1 times 10, which is 1 newton, then 0.4 times 10 is 4 newton. Okay, can I find the center of gravity between A and B, knowing the distance between them and knowing their weights? Yes, I know. So the weight of A over the weight of B equals BG over AG. Okay, the weight of A is 3, the weight of B is 1. Okay, start with the two lighter objects, it's easier like that. 3 over 1 equals BG, we don't know it, right? BG over AG, we don't know the distances, we don't know anything to do with distances. If you cross multiply, you're gonna get that BG equals 3AG, right? What else do we know about the distances here? We know that BG, let's say this is G here, okay? We know that BG plus AG is 8 centimeters. The total side is 8 centimeters. So BG plus AG is 8 centimeters. Can I substitute BG with 3AG? Yes, I can. So 3AG plus AG equals 8 centimeters. You're going to get 4AG equals 8 centimeters. You're going to get AG equals 2 centimeters. So this is from A to G is 2 centimeters. So this is from B to G is 6 centimeters. What will be the weight of the object here if it's 3 newtons and 1 newton? Obviously 4 newtons, right? So now I found the center of gravity between these 2 points. Now I have to find it between the center of gravity and here. So if you connect these 2 points, where will the center of gravity fall, knowing that they both have the same weight? Obviously at the midpoint. So you say that the center of gravity, okay, the center of gravity, I'm just going to show you the answer key, okay, the center of gravity, so in conclusion, the center of gravity is a point on G such that GD equals GC, so it's on the midpoint. GD equals GC, and AD is 1 over 4 AB. Okay, because this is 2, this was 6. Okay, it's 1 over 4 of the whole thing. 2 is 1 over 4 of 8, right? Okay, that doesn't matter, okay? Question 15. Okay, this is the good question. So I think it came. A pin is formed with a spherical tip of mass 5 grams. Okay, so the tip is 5 grams and the radius 1 centimeter. Radius over here, 1 centimeter. Attached at point A to a uniform rod AB of mass 10 grams and length 8 centimeters. So the mass of 10 and length 8 centimeters. Find the center of gravity of the pin. To start with, let's start with the center of gravity of the rod. And the center of gravity of the rod is obviously going to be 4 centimeters. 4 centimeters. Okay, so yeah, the first step is to take the center of gravity of the rod. It's a uniform rod. Obviously, the center of gravity will be at the midpoint. If the whole length is 8 centimeters, that means the center of gravity 4 centimeters. 4 centimeters. And then they said a sphere, radius 1. And the center of gravity of any sphere or circle will be the center of that sphere. So it will be 1 centimeter here. Okay, what do we know about the equation? We know the weight of object 1 over the weight of object 2 equals GG2 over GG1. Okay? Let's start with the lighter object. The weight of object 1 is 0.05 because you do convert this into kilograms. Okay? You convert it into kilograms, divide by 1000. Okay, then you multiply by 10. Okay, and you get 0.05. So weight 1 is 0.05. Then 10 grams, convert it to kilograms and multiply by 10. You divide by 1000, you get 0.001. Multiply by 10, you get 0.1. Equals GG2 over GG1. Okay, 0.05 over 0.1 is the same as 2 over 1. Sorry, 1 over 2, sorry. 1 over 2. You can do this on a calculator. Equals GG2 over GG1. So the same as the previous question, you have to use a system of equations. You're going to have to do substitution. So cross multiply, you're going to get 2 GG2 equals GG1. Okay, and then now, do we know how much the distances are? The total distance is from G, let's call this here G, this is G1, this is G2. What's the distance between them? 1 centimeter, 4 centimeters, 5 centimeters, right? So G1 plus G2 we know is 5 centimeters because it's 4 centimeters here and 1 centimeter from the sphere, right? Okay, we said GG1 is 2 GG2, so 2 GG2, we can substitute GG1 by 2 GG2 plus GG2 is 5. So you get 3 GG2 is 5. You get GG2 is 5 over 3, which is 1.67 centimeters. Okay, if you wanted, so it's going to be like here, somewhere. So this distance here is going to be 1.67. If you wanted to find the distance from B to here, you just do 4 plus 1.67. But they didn't ask it, but for some reason they put it in the answer key. 4 plus 1.67, 5.67. Question 16. Okay, question 16. Given a uniformly thin flat object of regular shape, what's the best way to find it? You're gonna have to poke 2 holes, find this, hang it from both extremities, and then draw 2 lines and check the intersection. So suspend the object from a fixed point and allow it to settle in equilibrium. Using a plumb line, draw the vertical line which connects the point of suspension to the center of gravity. Repeat the procedure using several points, and then the point of intersection of all of these lines would be your center of gravity. A uniform meter ruler AB of weight 0.95 newtons is supported on a knife edge placed at 45 centimeters from A. Okay, the meter ruler balances horizontally when a mass of 48 grams is suspended at a distance x from A. Where? Distance x from A. Okay, find the value of x. So step 1 when working with these types of questions is to identify all your forces. Okay, and they drew it for you, so they made their lives a bit easier. The weight is 0.95 newtons, fellas, 0.95, and the tension here, T, is gonna be, since it's 48 grams, divide by 1000 to make it kilograms, and multiply by G, which is 10. 48 divided by 1000, 0.048, multiply by 10 because W equals mg. 48 divided by 1000 times 10, you're gonna get 0.48. So this n here will be 0.48 plus 0.95, which would be 1.47. Okay, we know that this is the weight, and it's a uniform ruler. In any stick, where does the weight act? The weight acts on the center of gravity, right? So since this is the center of gravity, and it's a uniform stick, you know the center of gravity, that means it's split into two equal parts, 0.5, 0.5, because it's a uniform meter stick. Okay, keyword uniform. So the distance here is 0.5 meters. So the second step after identifying all forces when working with this question is to choose our point of moments. Let's choose point A. Okay, and we know sigma m equals 0. What is the moment of the weight around A? Let's see. It's gonna be going this direction, which is clockwise. So negative 0.95 times 0.5. Then the moment of n around A, which is going like this, which is counterclockwise, so it's positive. So 1.47 times the distance, which is 45 centimeters. So we need to make it a meter, so 0.45. And then the moment of t around A would be, is it going clockwise or counterclockwise? Going clockwise. So negative 0.48 times the distance x, right? We know when we add all of these up, we get 0. So if you multiply these out, you get negative 0.475. Okay, if you multiply these out, you get 0.6615. And if you multiply, this stays as negative 0.48x. So let's write this down. Negative 0.475 plus 0.6615 minus 0.48x equals 0. So if you combine these two, you're going to get 0.1865 minus 0.48x equals 0. And take this to the other side and divide by 0.48. You're going to get x equals 0.1865 divided by 0.48, which is equal to... Okay. Sorry. I'm taking a look one more time. It's not 1.47, it's 1.43. So our calculations were wrong. So here it was 0.6435. 6435. Here also 0.6435. And if you combine them, you get... So you get 0.1685 over here. And also over here. And if you divide them, you get... Let me check. You get 0.35. Okay, this is in meters. Okay, so you can keep it as 0.35 meters or change it to centimeters, whatever you want. Okay, so for this one here, he uses a spanner which is 24 centimeters long. Okay, it was 24 centimeters. Okay, calculate the moment of his pull if he pulls at right angles with a force of 50. So if he pulled with a right angle, okay, we know D perpendicular, say from here, from A, is 24 centimeters, but it has to be in meters, so 0.24. And we know force. So the moment is FD perpendicular, right? So in this case, it would be 50 times 24, 0.24, because it has to be in meters, and you get, how much do you get? 12. Okay? They're saying, what if the angle increased from 90 to 120? So let's erase this. Okay? What if it increased like this? 120 degrees. Okay, you have to look at it. Now we always need D perpendicular. So draw the line of action of the force. Draw the line of action of the point of moments. Where is it perpendicular? Over here. So we need to find this distance over here. Okay, we know this angle is 60 because 180 minus 120 is 60. So when you're in a situation like this, and we want to find this distance, you just do times sine 60. Okay, so you do 50 times 0.24 times sine 60. Okay, if you get a question like this, always do sine 180 minus the alpha given. Okay, just do that. So yeah, in this case, you do 50 times sine 24, sine 60 times 0.24, and you get 10.4. So what's gonna happen when the angle increases? The moment will decrease. Okay, the adjacent figure shows a man of mass 90 walking on a beam of mass 80. The beam is hinged at A and hung at B by means of cable that can withstand a maximum load of 1000 newtons. How far from the hinge can this man move before the cable breaks? So look here, we know that it's balanced, right? It's being balanced, so we should know that sigma m equals 0. We have three moments. Okay, the first step, identify all of our forces. We have the weight of the man, we have the weight of the beam, and we have the force acting on the cable. Let's start with the weight of the beam. The weight of the beam, since it's a uniform beam, the weight always acts at the center of gravity. And since it's a uniform beam, the center of the gravity will be at the midpoint. So its weight will be 800 newtons because it's 80 kilos. 80 times 10. By then, the weight of the weight of the man, since 90 kilos, the weight will be 900 newtons, right? Then we have the force acting by the cable, and we know it's 1000 newtons. So now we have to know our point of rotation, and we said it's hinged at A, so A is our point of rotation. So we need to find the moment of everything. Let's call this the moment of the weight around A. What's it gonna be? It's gonna be, since it's going clockwise, right? Clockwise, yeah. It's gonna become negative 800 times 3 equals negative 2400. The moment of the man around A is gonna be negative 900 because it's going clockwise times the distance D, right? Times D. We don't know it. Okay, we don't know the distance. We're trying to find out where the man is standing. Then the moment of the cable around A, which is positive because it's going counterclockwise. Yeah, positive 1000 times the distance, which is 6 meters, is given here, 6 meters. Okay, which is 6000. So if we add this all up, we're supposed to get 0, right? Sigma m equals 0. So negative 2400 minus 900d plus 6000 equals 0. Negative 2400 plus 6000 is 3600 minus 900d equals 0. You're going to get d equals 4 meters. So the maximum length that he can stand is 4 meters. Question 20. A man of mass 70 kg. He is standing on a plank of mass 100 kilograms, resting on 2 trestles as shown in the diagram. Knowing that the plank is homogeneous and uniform. Find the magnitude of the vertical forces acting by the 2 trestles when the man is 2 meters from A. The first thing you should do, أول شيء, is identify all your forces. Okay, we have the man, which is 70 kilos, yani his weight will be 700 newtons. Then we have the plank, which is 100 kilos, so its weight will be 1000 newtons. I don't always know, since it's a uniform plank. Okay, oh well, they didn't say. Yeah, they said the plank is uniform and homogeneous. That means the weight will be acting at the center of gravity, right? So if this was 3 meters, this would be 1.5, this would be 1.5. Okay, but let's not write that to confuse you guys, so we don't confuse you. Okay, we said it's 2 meters from A. The man is 2 meters from A. If this is 2 meters, okay, and this is 1 meter, so obviously this distance here would be 1 meter from B, right? And if it's 1 meter from B, then if this whole thing is 3 meters, then the distance between the man and C will be 2 meters, right? 2 meters plus 1 meter gets you the whole distance, which is 3 meters. Okay. We know that there's going to be a force B acting upward and a force C acting upward, right? Let's take now, we don't know what B and C is, right? We're going to take C as our point of moments, right? Step 2 is always take a point of moments. We located our forces, now we're taking a point of moment. Let's find the moment of the man around C. It's going to be the force 700 and it's going this way, it's going counterclockwise, so it's positive. So positive 700 times the distance, which is, we said the man is 2 meters away from C, right? Times 2 is 1400. Then the moment of the weight of the plank around C. It's going in the same direction, so 1000 times the distance 1.5 equals 1500. Then the moment of C around C, obviously there's going to be 0, right? Because it intersects with the C. The line of action of C intersects with C. Then the moment of B around C, B now is going clockwise, so it's going to be negative, right? So it's going to be negative. Okay, the force of B, we don't know, we're trying to find it, right? So we just call it F times the distance. How far is B away from C? It's 3 meters, right? Times 3. So you get negative 3F. And we know that since it's balanced, sigma M equals 0. So add these all up and you get 0. So 1400 plus 1500 minus 3F equals 0. If you solve for F, you get 966.7 newtons. Okay, this is the force of B, right? Let's call this force of B. Can I find force of C? Yes, I can. You can do the opposite and take B as the point of moments and then solve, or you can directly do 1700 minus 966.7. Why? Because I know that this is 700, this is 1000, and we know that the resultant force down should be equal to the resultant force up, right? So 1700 minus, if this one's 966.7, then just 1700 minus this one, and I'm gonna get this force here. Okay, and you should get 700 something. You get 733.3. So you get the force of C 733.3 0.3. Okay, find these forces when the man is standing straight at B and then straight at D. Okay, when the man is standing here at B. So now it's the same concept. Identify our force. Go through the same steps. Identify our force. We have the weight of the man, which is 700. We have the weight of the plank, which we said is 1000. Okay, remember because W equals mg, huh? And then we have the force of B and the force of C. It would be easier to take B as the center of moments because then you could cancel out this force and you can cancel out this force. Okay, so let's take B as our point of moments over here, point B. Okay, now let's find the moments for each force. Obviously, the moment of the weight of the man, around B is 0, and the moment of B around B is 0. The moment of the weight of the plank around B, since it's 1.5 and it's going like this, it's going to be negative, right? So clockwise, so it's going to be negative 1000 times the distance, which is 1.5, because we said it's at the midpoint of 3. So times 1.5 equals negative 1500. Then the moment of C around B, it would be the force C, right? The force of C. Is it positive or negative? It's going counterclockwise, so positive, times the distance, which is 3. So which is 3 times force of C. Okay, and we know that since it's balanced, sigma m equals 0. For negative 1500 plus 0, 0, plus 3 fc equals 0. So you're going to get the force of C is 500. Can we find directly the force of B? It's going to be 1700 minus 500, which is 1200 newtons. Remember the unit, huh? Why do you do 1700? Because we said the sum of the upwards should be equal to the sum of the downwards. Okay, 1700 is the downward minus 500 here, so 1200. Then they said if the man was at D. Same concept. You have the man at D over here. Okay, his weight would be 700. Okay, same thing. Plank would be 1000 newtons. Okay, again we're gonna have a force B and a force C. Okay, we're gonna want to cancel out either B or C, so you can take B as your point or C as your point. Doesn't really matter. Let's take B as our point. Okay, so we're gonna have moment of B around B, which cancels, gets me 0. Moment of the weight around B, which is gonna be going clockwise, so in the negative direction, times the distance between the midpoint and B, which is 1.5, which is negative 1500. And then you're going to have the moment of C around B, which is going to be the force of C. We're going to say the force of C, and going counterclockwise direction, right? So positive, times the distance between them, which is 3. So it's going to be 3 times force of C. Okay, and then the moment of the man around B, which is going clockwise, right? So negative 700 times the distance. It's 3 meters, 4 meters. So, sorry, 3 meter, 1 meter, so 4 meters. So times 4, which is negative 2800. So negative 2800 minus 1500. They have that plus. Negative 2800 minus 1500 plus 3 FC gets me 0. If you solve this, you're gonna get FC equals 1433.3. Okay, then that's the force of C. How do we find force of B? Same thing, 1700 minus 1433.3. What do you get? You get 266.7. If the trestle at C moved towards B, okay, what is the position beyond which the plank will topple when the man is at D? Hint, think what should be the force by the trestle B in this case. So, when they say the plank will topple, it means that, let's say the man is standing here. We're going to keep on moving this triangle here all the way until at some point, خلاص, okay, it stops holding and the plank becomes bent like this. You realize now how it's not touching B anymore, but it's bent upwards so that it's not touching B, right? The man is pushing the plank down, so it's not touching B anymore. So what does that mean? They even said it in the hint. What's the force by B in this case? If B isn't touching the plank anymore, what's the force by B? Force being done by B equals 0. Okay, if B is doing no force, how much will force of the C be? To be 1700 newtons. So C will be doing all of the force. All of the effort will be being done by C. Okay, now we know that sigma m equals 0, right? We have the moment of the man and the moment of the weight. Okay, we're going to take B as a reference point. The moment of the man around B is going to be his weight 700. Okay, around B it's gonna be clockwise, so negative 700 times the distance, 4 meters. 3 meters, 1 meter, 4 meters. So negative 700 times 4 equals negative 2,800. Then the moment of the weight around B is gonna be 1.5 meters, that's right? So distance is going to be 1.5 meters, and the weight is 1,000 newtons. And we're going clockwise, so negative 1,000 times the distance between them is 1.5, because half of 3, it's at the midpoint, weight is at the half, negative 1,500. High negative 2,800. Okay, the moment of B around B akid is going to be 0, and the moment of C around B is going to be the force of C, which is going upwards. It's going counterclockwise, right? So it's going to be positive 1,700 times the distance, which we don't know. We're trying to find it, right? D. And we know sigma m equals 0, so add these all up, you get 0. So negative 2,800 minus 1,500, okay, plus 1,700 D equals 0. If you solve for D, you're going to get D equals 2.53 meters. And this is us taking B as the reference point. So 2.53 meters from B. Question 21. A girl, how much left here? 2 pages. Okay, nice. A girl, yeah, so a girl of mass 50 kilograms sits on the right hand side of a seesaw. This always comes, I remember. Okay, so 50 kilograms on the right hand side of a seesaw at a distance of 3.4 meters from it. So let's say the pivot is here, 3.4 meters. Okay, another girl of weight 450 newtons sits on the left hand side. Okay, so here she's sitting 450 newtons. Okay, this girl here is 50 kilos, so her force would be 500 newtons. Okay, at what distance from the pivot must she sit to balance the seesaw? Okay, so you can just do 500 times 2.4 divided by 450, because the moment of, let's call it girl A, moment of girl B, they should cancel out. So moment of A should be equal to moment of B. So you can do 450 times D, the distance, we don't know how much. Okay, equals 500. That's 5,000. 500 times 3.4. And you should get the correct answer. 500 times 2.4. Okay, whoa, that's a lot. Yeah, so you get, yeah, 3.8 meters. Pretty easy. Make sure to convert your units, okay? This won't come, I'm not even gonna bother. Question 23. The center of mass M of different shapes is shown below, which is not stable. This will come, okay? If the center of gravity intersects with the floor, then it's stable. Let's see, M intersects, so عادي, it's stable. M here intersects, عادي. M here does not, so it's gonna tilt over. M here, it's fine. Okay, so here it's not stable. C is not stable because it doesn't intersect with the floor. Shape C is not stable since the vertical line passing through its center of mass does not intersect the baseline of the shape. Yeah. 24. A boy is moving up a ladder of weight 50 newtons, okay, placed next to the wall. Okay. The horizontal force exerted by the wall on the ladder has a magnitude of h 250 newtons. The vertical force exerted by the ground on the ladder is denoted V, and the ladder is in equilibrium as long as the horizontal distance of the boy from B is less than x. Use G is 9.8 meters per second. Okay. F, okay, they could bring this in the written. The mass of the boy is 40 kilograms. Calculate the magnitude of his weight. Obviously, W equals mg. So 40 times 10. Sorry, no, 40 in this case times 9.8, because they said G is 9.8. Is going to be how much? 392 newtons. Calculate the moment of the weight of the ladder W around point B. So the moment equals FD perpendicular, right? The weight of the ladder is given 50, and it's going like this. It's going down around point B, and it's gonna go like this. So it's counterclockwise, so it's positive, right? So here we can put it 50 times the distance between them is 1.5. Okay, and you're gonna get 75 Newton meter. Okay, please make sure to put the unit. Calculate the moment of force H around point B. So H is over here, point B is over here. Okay, the moment here will be for force H about it's gonna be F D perpendicular, right? The force H is 250 newtons, okay? Even though it's going clockwise, they didn't say specify direction and stuff. They only said moment, so there's no need, okay? Hatta here, you didn't have to be positive or negative in part B. 250 times the distance. Okay, the distance will not be the length of the ladder. No, it's going to be D perpendicular. So go like this. Line of action, perpendicular. Find distance from here to here. It's given 2.8. So times 2.8. And what do you get? You get 700 Newton meters. 700 Newton meter. Deduce the maximum distance x from point B that the boy can move through without disturbing equilibrium. For part D, so they're going to want the maximum distance x from point B that the boy can move through without disturbing equilibrium. So part A, B, C actually is going to help us. Okay, we know that the weight of the boy is 392 newtons. Okay, we have here 392 newtons. Okay, we know that the moment of the ladder W is 75. Okay, we want equilibrium, so know that sigma m equals 0. What are the moments we have? We have the moment of H, moment of small w, and we have the moment of this big W here, right? And we also have the moment of V. Okay, so we have 4 moments. Moment of H around B, moment of V around B, moment of the small w around B, and the moment of the big W around B. The moment of H around B we got is 700, okay? But I'm working with sigma m, for it's supposed to be negative 700 because this was going clockwise, and I told you guys, in the question when they just ask for a moment, there's no need to specify. But see, when you're solving for sigma m, it has to be the correct sign, negative 700, because it's going clockwise, right? Okay, negative. Moment of V around B, it intersects with B, obviously it's going to be 0. Moment of the small weight around B, the force is 392 newtons and it's going in the counterclockwise direction, so it's going to be adi 392 times the distance. We're trying to find that distance x, right? 392x. And then the moment of the big weight around B is going to be, we found it here, 75. Okay, this was already correct because it's positive, it's going counterclockwise. Okay, we know the sigma m is equal to 0. So if you add all these up, we're going to get 0. So negative 700 plus 392x plus 75 equals 0. And solving for x, you're going to get x equals 1.594. So we can just round it to 1.59 meters. Part E, deduce the magnitude of the force V. Then part E, they're saying deduce the magnitude of the force V. In the question, they said the V is the force exerted by the ground on the ladder. Down here, we have 392. Here we have 50 newtons, right? From part A, and 50 is given in the question. So obviously, we just add them up, and we get 442 newtons. Is this correct? Yes. Okay. What other force acts on the ladder to keep it in equilibrium? State its direction and point of application. Obviously, it's going to be friction, okay? What's stopping a ladder from moving? Obviously, it's going to be friction. And where does it act? It acts right here, right? It should be at B. And its direction is opposite. It should be like this. What's the answer? Friction acting at B, directed horizontally leftwards, obviously. Friction acting at B, right? Where the surfaces touch. And it's acting to the left. That's it, I think, here. Yes, okay, we're done. Chapter 4. Okay, so it's now chapter 7. Describe Thomson's atomic model. Thomson's atomic model is the atom. What did he think of the atom? He thought the atom was a collection of tiny electrons dispersed in a positively charged medium. So back then, the generalization of an atom was they usually thought of electrons. And what kept these electrons in touch? They thought there was some positive medium keeping it in touch. So Thomson was electrons dispersed in a positive medium. Okay. Then Rutherford came and disproved this, and he figured out that the atom consists of a positively charged heavy nuclei around which light electrons revolve, like planets around the sun. Okay, so Rutherford came and said, oh, well, there's this big heavy nucleus in the middle which is positively charged, and then comes these small electrons around it. Okay, the element thorium is radioactive. What is the number of nucleons in the nucleus of a thorium atom? 234. Am I wrong? Yeah. Nucleons is just the mass number. Okay, what gives the atom its mass? It's the nucleons. Describe the subatomic particles of an atom. We have neutrons, electrons, and protons, right? We have the proton, which is positively charged in the nucleus, electron, which is negatively charged, located in the electron cloud, which is around the nucleus, and then we have the neutron, which are neutrally charged and in the nucleus. The chemical symbol of a carbon atom is 12 6. What is the atomic number? Obviously 6. And what is the mass number? Obviously 12. Isotopes are elements of the same sorry, isotopes are atoms of the same element, okay, who have a different mass number. So they would have the same atomic number but different mass number. So they are nuclides. Nuclides, by the way, are basically the same element, okay. Sorry. Nuclide is the definition of a specific element, okay? Any specific element having the same atomic number but different mass number are called isotopes. Therefore, they're the same element but the nuclei contain different number of neutrons, blah, blah, blah. Okay, write down the nuclear composition of the following 3 isotopes of hydrogen. Which is the composition? Okay. Yeah, obviously, H1 is 1 proton. Then the neutrons is 1 minus 1, 0. So 1 proton only. Here is 1 proton, 1 neutron, because 2 minus 1. 1 proton, 2 neutrons. Which is the heaviest? Obviously, H31 is the heaviest. What are the types? Carbon 14 is an isotope of carbon. It's radioactive decaying to nitrogen 14. Write an equation for the decay of carbon 14. So we have carbon 614, right? It decays to form nitrogen 714. Okay, we need to add something here. Did the mass change? No, so it's 0 up here. But it changed over here. Okay, how do I figure out what to add? I do this side minus this side. 6 minus 7 is minus 1. So I have minus 1 here. What has a charge of negative 1 but no mass? Obviously, it's an electron, right? Or we could say a beta minus particle. We're going to say electron. What are the types of radioactive decay? The different types of radioactive decay are alpha, beta, and gamma. Define nuclear fusion. Nuclear fusion is the combining 2 lighter nuclei to form 1 larger nucleus. Okay, nuclear fusion is in a reaction in which 2 or more atomic nuclei are combined to form 1 or more different heavier nuclei. Question 11. Describe alpha, beta, and gamma decay. Okay, I think you have to give the properties of each one. Or let's see. Okay. So, okay, alpha is obviously positive. It's a helium nuclide. Okay, you have to know that it has the most ionizing effect and the least penetrating power, and it's the slowest velocity because it's the heaviest one. Okay, beta is negatively charged. It's an electron particle. Its speed is near the speed of light. Okay, so its velocity is near the speed of light. Its penetrating power is medium, and its ionizing effect is medium. So beta is in the middle. Then gamma is, what is gamma? It's radiation. It's EM radiation, electromagnetic radiation. Its velocity is the speed of light, and it has the most penetrating power but the least ionizing effect. And what is its charge? It's uncharged. Describe the penetrating power of alpha, beta, and gamma. Alpha has penetrating power that is stopped by 1 sheet of paper. Beta can be stopped by 1 millimeter of aluminium foil. And gamma radiation cannot be stopped, but 4 centimeters of lead can reduce its penetrating power to 10%. So alpha particles have a weak penetrating power and can usually be stopped by 1 sheet of paper. Beta particles are fast moving, which can be stopped by a book. Okay, you can say a book. Gamma rays are very energetic with no mass and no charge. They never completely stop. Gamma can never be stopped. But you have to know that a thickness of 4 centimeters of lead can reduce its intensity to 10% of its original value. Okay. Alpha, beta, and gamma radiations are emitted by a radioactive source S as shown in below. Okay, in the region of space surrounding the source, a magnetic field is pointing into the page. Determine the path followed by each radiation. If it's going into the page, I'm gonna write for you the rules. Okay, so you don't have to do the right hand rule in the exam. If it's going into the page, alpha will go up. Gamma, no, it's not gamma. Gamma will go middle, okay, and beta will go down. But if it's going out of the page, alpha will go down, gamma will go middle, but now beta will go up. So they swapped. Into, alpha will go up. Always know alpha and beta are opposite, okay? Into, alpha will go up. Out, alpha will go down. How do you know? If it's an X, it's going in. If it's a circle, like this, it's going out. How do you differentiate between it? And I like to think of it as a screw. When you're screwing something in, then you'd see the tip of the screw and it would be the X. But if you were unscrewing something, you would be seeing the screw coming out. And the screw coming out is the tip of the screw, which is a circle. That's how I memorized it. Okay. Question: explain how the GM tube works and how to measure background radiation using the GM tube. Yeah, so explain how the GM tube works and how to measure background radiation using the GM tube. Just go to the solution. Okay, the GM tube stands for Geiger-Miller tube. Okay, I doubt this will come, but like read over it. The tube operates under a voltage of about 400. A single particle of radiation hitting the tube creates a pair of ions in the tube which are attracted to oppositely charged electrodes, creating blah 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 blah. Okay. You can read this if you want. I doubt it will come. Okay, describe the tracks left by alpha particles, beta particles, and gamma radiation in a cloud chamber. Okay, these you need to know them. Okay, in a cloud chambers, alpha leaves a bold tracks and moves in a straight line. Okay, alpha will be straight line. Since beta particles have weak ionizing power, the tracks left are very faint compared to the bold alpha tracks produced. A gamma photon produces no tracks in a cloud chamber. However, if you really light it with an intense beam, okay, the electron tracks show a wispy image in a cloud chamber. Let me show you. Wait. So over here, these would be alpha. They would be bold and straight. Okay. Then you'd have wait, hold up. Beta. Oh, let me go back. Hold up. Okay. These would be beta. Okay, they would be less faint. I mean, they would be a bit more faint. Okay, and they would be how does he say it? How do you describe it? They're faint. Yeah, they're faint compared to the alpha. But then for the gamma, okay, they won't show. But if they were blasted with, blasted with an intense beam, okay, this is how they would show. It's a wispy image. Wispy image, and it's going all over the place. Okay. So these are the tracks. Alpha would be straight and bold. Beta would be fainter than alpha. Gamma would show a wispy image. A radioactive source emits all types of radiations that follow different paths when exposed to an electric field as shown below. Determine the path followed by each type of radiation. Obviously, the one attracted to the negative would be the positive one. And which one's attracted to the positive one? Alpha. Which one's attracted to the positive one? Negative. Okay, and that would be beta. Okay, and which one continues straight? It will be gamma. Okay. So, yeah. Okay, what is meant by the half-life of a radioactive element? Okay, the half-life is the time taken for half the quantity of the material to decay. Okay, question B. Explain how you can clearly determine the half-life. Okay, you could just take 2 points. This isn't gonna come, but see, just so you understand. From a graph, how can you clearly determine the half-life? Just take any point. Let's say this point has time 1, mass 1. You're gonna look for the point such that the mass of it is half mass 1. Okay, and then you're gonna find the time. Then how do you find how long the half-life is? You just do time 2 minus time 1. Okay, you just look on the graph. So take 2 points, T1 M1 and T2 M2, such that the second mass is equal to half of the first mass. Okay, then calculate how long T2 minus T1 is. Okay, from the graph, from the graph of mass versus time. Okay, then activity versus time, same thing. Okay, take the point T1 activity 1 and take point T2 activity 2, such that the second activity is half of the first activity, and then do T2 minus T1, same thing. Part C. Carbon has a half-life of 5600. Draw a graph to show the decay of carbon-14 from an initial activity of 64 counts per minute. So I'm not going to draw it for you, but how you're going to do it if this does come, have your activity in the y-axis, okay, and put counts per minute. Have your time, obviously, in years, because the half-life is in years. So you're going to start it off at 64, right? We're going to start at 64. And we know that the half-life is after 5600. So you're going to put time 5600 years, right? And you're going to curve it down. Obviously, at 5600, it will be half of 64, so it's going to be 32, right? So then you just connect the 2 points and curve it down. Then, after 5600 more years, it's going to be at the time 11,200, because 5600 plus 5600 would be 11,200. So from 32 to 11,200, since it's halving, it's going from 32 to 16. So now connect them and half. Then after 11,200, you can put the time plus 5600, it will be 16,800. Okay, over here, and it was at 16, it halves, goes to 8. Okay, then again, adds 5800, it halves and goes to 4, and so on and so forth. That's how you do it. Okay, question 18. Express the decay of uranium into thorium and beta decay. So express the alpha decay of uranium into thorium and the beta decay of carbon into nitrogen. Okay, since I said it's a beta decay, فيعني U92 234 gets me thorium. Okay, and we know that it's alpha, right? Sorry, alpha decay here, مش beta. Alpha يعني helium 4. How do I know how much this is? 92 minus 2, 90. 224, 234 قصدي. 234 minus 4, 230. So this is how you write it. That's it. Then decay of carbon into nitrogen. Beta decay, huh? C614 gets me N plus beta. Beta will be, if they just say beta, yani it's negative, huh? Unless they say positive beta, then you put it positive. But for now, we keep it negative. So 6 minus minus 1 will be 7. 14 minus 0, 14. Okay. Question 19. Using the laws of conservation of number of charge and mass, complete the following reaction. 14 minus 14, 0. 6 minus 7, minus 1. And it's just what we just did now, so obviously it's an electron. Iodine 131 is a radioactive element with a certain half-life. 50 grams of iodine decays. 50 grams of iodine decays, and after 24 days, the remaining quantity is 6.25. What is the half-life of iodine? So here, when they give you the final initial mass, the final mass, and they ask for you to find the half-life, okay, you're gonna use the equation. The final mass is equal to the initial mass over 2 to the power of n, because we have this initial mass and we keep on dividing by 2 by 2 by 2, so we just keep the 2 raised to the power of n, which is the number of half-lives. So in this case, our initial mass is 50 over 2 to the power of n equals our final mass, which is 6.25. Okay, we can find 2 to the power of n by just dividing 50 by 6.25. 2 to the power of n is 50 divided by 6.25, which is equal to 8. So 2 to the n equals 8. And 2 to the power of what equals 8? Obviously, that's 3. Okay? So we have n equals 3 half-lives, right? In how long? 24 days. So 24 days is 3 half-lives. X days would get me 1 half-life. How many days would that be? Just cross multiply and you're going to get x equals 8 days. So 1 half-life would be 8 days. Question 21. State the safety precautions that you should follow when dealing with radioactive materials. هو اللي لازم تحفظهم. Okay, you have to memorize it. Okay, never move it with your hands. Always use tweezers. Make sure that it's pointing away from you. Don't do it by eye. It should be done by color or number. Okay, they should be attended by responsible personnel. Okay, and when done with, they should be locked up in a safe place. For example, a lead box. Okay, because the lead traps the radiation. When handling radioactive sources, eating and drinking and smoking are prohibited. You're not allowed to eat, drink, or smoke. After you're done, make sure you wash your hands very well. Okay. Question 22. The element thorium is radioactive. It decays by emitting beta particles and has a half-life of 24 days. What is a beta particle? We know it's an electron, right? Is it an electron? Yeah. Okay. What? Calculate the number of protons and neutrons in the nucleus of an atom of thorium. Okay. How much is the protons? It's 90. How do you find the neutrons? Neutrons, 234 minus 90. You're gonna get 144, I think. Yeah, 144. Okay. Part C. Calculate the number of protons and neutrons in the nucleus formed when a thorium atom emits a beta particle. So thorium, 90, 234. Okay. Get me a new thorium atom. Okay, we don't know how much. Plus a beta particle. We know beta is minus 1, 0. How much will the thorium be? 90 minus 1, 89. Wait, no. It's supposed to be 91. 90 minus 1, sorry. You subtract 90 minus 1 gets me 91. And then 234 minus 0, 234. Okay, so how many protons will I have? I'll have 91. And how many neutrons will I have? 234 minus 91 will be 143. Is that correct? Yes. Calculate the time taken for 1 gram of thorium to decay, leaving 1 over 8 grams of thorium unchanged. Okay, so calculate when you have initial and final mass. You do mass final equals mass initial over 2 to the power of n. If a mass initial is 1 gram over 2 to the power of n equals 1 over 8. And 1, so you're going to divide 1 by 1 over 8. So 1 over 1 over 8 gets me 2 to the power of n. You can get 2 to the power of n equals 8 again, and n equals 3. Okay, so it's 3 half-lives. How much time is that going to take me if each half-life is 24 days? Just do 3 times 24, gets you 72 days. Question 23. To determine the age of a 20-gram piece of charcoal taken from an ancient campfire, a sample of wood of the same mass has been cut from a living tree, and the activity of carbon-14 of both pieces has been recorded. The new piece shows an activity of 320, while the old one showed 40. How old is this piece of charcoal if you know that the half-life is 5,730 years? So for activity, you're going to use the same thing. Final activity equals initial activity over 2 to the power of n. Okay, initial activity is 320 and the final activity is 40 equals 2 to the power of n. So you're going to get 2 to the power of n equals 8. So n is 3 half-lives. Okay, if each half-life is 5,730 years, how old will it be? 3 times 5,730. You're going to get 17,190, I think. Yes, okay. Question 24. A doctor suspects that one of the kidneys of a patient is not working properly. The doctor injects him with the radioactive impurity, 1 megabecquerel iodine of iodine 131, and the half-life of it is 8 days. Okay, this travels to his kidneys. A normal kidney gradually removes all impurity in about 20 minutes. So, okay, wait, let's see this. So if you realize here, the right kidney loses all its radiation in 20 minutes, but the left kidney actually gains in 20 minutes. So obviously there's something wrong, yeah? The radioactivity in his kidneys is monitored using gamma ray detectors. The graph above shows the result. Which kidney do you think is not working properly? Obviously the left kidney. Why? Because it doesn't get rid of it. The left kidney is not working properly. From the previous graph, it's clear that the kidney is removing the radioactive impurity. That is shown by the increase of activity over the first 20 minutes. Yeah, so the kidney is supposed to remove the radioactive impurity. Here, it's increasing the activity. So, yeah. Why do you think that a gamma ray emitter was used as the injected impurity instead of a beta emitter? Because the penetration power of a gamma will pass through everything, but a beta might not. Okay, the penetrating power of beta is very weak, while gamma can easily penetrate. Why would it be less suitable to use an impurity? Why would it be less suitable to use as an impurity a material with a short half-life? If it had a short half-life, then it would be removed very fast, right? A short half-life material would significantly decay before being removed by the kidneys. So بيكون خلاص راحت before the kidneys uh, removed it. That's why we need to use a long half-life so it lasts. Give 4 facts about fission. So 4 facts would be neutrons are given off in fission. Okay, not alpha, beta, or gamma. No, it's neutrons. In a fission reactor, each fission is caused by neutrons from a previous event, and therefore it is not spontaneous. Okay, but it can be spontaneous. Since each occurrence of fission is caused by a previous occurrence, the reaction is called a chain reaction. Okay, it could be spontaneous. I remember it being a choice. Fission may be spontaneous. I remember being a choice in the multiple, so you can choose it. If they say fission may be spontaneous, you choose it. There are many possible byproducts from a fission event, since the nucleus may split into many different combinations of 2 daughter nuclei, and it can produce heat at a controllably significant rate. So you can control the rate of the fission. Okay, it's controlled energy. Question 26. What are some advantages of nuclear? Nuclear energy is a clean form of energy, right? It doesn't produce exhaust gases. And also, a nuclear reactor can produce their own fuel, which means that there will never be a shortage of fuel. Okay, and it doesn't contribute to global warming. 27. What are some disadvantages of nuclear energy? What are the disadvantages? It's expensive, obviously. Okay, the radioactive wastes are produced, which you have to bury. They're hard to bury. Obviously, people are scared. There's psychological bias, and people are scared also of nuclear weapons. 28. Emissions from a radioactive source pass through a hole in a LED screen and into a magnetic field as shown below. Okay, so radiation detectors are placed at A, B, and C. They give the following readings: A, B, C. The radioactive source is completely removed, and the readings on C are measured to be this. Okay, explain why there are still counts being recorded at C even when the radioactive source has been removed, and give the reason for them changing over time. Okay, even if there's no source, C is detecting radiation. So what is that? Obviously, that's going to be the background radiation, right? And then they said, explain why is the background radiation changing over time? Okay, background radiation is completely random. Okay, so if they ask you why is it changing, it's because it's random. From the data given, deduce the type of emission being detected, if any, at A, and if any at A, at B, and at C when the radiation source is present. State the reason. Okay, here it's into the page because it's a dot. Okay, at C it's not detecting anything. What do we say when it's going into? We said when it's going in, Up would be alpha, middle would be gamma, and then down we said is beta. Okay, so let's see here. A in this case would be alpha, here it would be alpha, here it would be gamma, and here it would be beta. Okay, let's see. Do we have anything being detected at A? Yes, it's being detected. So alpha radiation is being detected at A. At B, do we have anything being detected? Yes, it's flowing straight. Right, we have it being detected, so that means at B we have gamma. Then at C, do we have anything detected? No, it's very low. So that means we do not have any beta particles present. Okay, so uh, wait, my fault. If it's a dot, then it's out, not in. If it's out, and we swap everything. Up would be beta, mid would be gamma, and down would be alpha. Okay, and the same rules apply. So up here would be beta, here would be alpha. So same thing applies. Since there's radiation being detected at A, that means we have beta present. At B, we have radiation, so that means gamma will be present. But C, we don't have radiation, and alpha won't be present. For my mistake, sorry, I didn't realize that it was out. I thought it was in. So that's why beta will be present at A, gamma will be at B, C will have nothing. So beta radiation is detected at A because negative charge will go counterclockwise in magnetic field. Okay, blah 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 blah. You don't have to say this. Okay, but okay, actually no, know that it's counterclockwise. So it starts here. If it goes up like this, that means it's going counterclockwise, right? This is counterclockwise. So know that negative particles will go counterclockwise when it's outside. So in case that comes multiple choice, negative particles are always counterclockwise when it's going outside. Gamma is at B because gamma gaze are neutral, so they're not deflected. Then nothing reaches C from the source. I think we're done this question. 6 different nuclides have nucleon and proton numbers as follows. Nuclide A has this. Okay, state which two nuclides are isotopes of the same element. أكيد it's gonna be C and E. Why? Because they have the same. Wait, sorry. Isotopes. Sorry. Isotopes يعني same proton number. يعني 92. B and E. Because they have the same number of protons but different number of mass. So over here. 29. B and E are isotopes of the same element because they have the same proton number. Then part B, plutonium-238 has a half-life of 88 years. At a particular instant, the activity of a sample of plutonium is 85. Calculate the time taken for this sample to fall to 25 becquerels. So always know final activity is equal to initial divided by 2 to the power of n. So it's going to be initial activity, which is 85 divided by 2 to the power of n equals 25. So 2 to the power of n equals 85 divided by 25, which is 2 to the power of n equal to, it's equal to 3.4. Then to find n, you have to take ln 3.4 divided by ln 2. So n equals ln 2.4 divided by ln 2. So because I'm doing this because n is an exponent, huh? You can't just divide 3.4 by 2. No. You have to take ln from both sides. Or if you want, some people do log. Some people do log base 2, 3.4, whatever. Okay, you can do that as well. But after doing that, you're gonna get n equals. And I don't know why it's written like 3.4, huh? Not 2.4. So this answer, you're gonna multiply it by 88 years. Okay, the amount of half-lives times each half-life is 88, and you're gonna get or something around 155 years. Okay, explain, because you're multiplying the half-life times the years for each half-life. Explain what happens to plutonium as activity of its sample decreases. We just say it begins to decay, right? Nuclides decay, change into other nuclei. Okay. Explain what the activity of plutonium-238 used in a laboratory for 2 months may be regarded as constant. Since the half-life is 88 years, okay, 2 months is barely anything, right? 2 months is like 2 over 12 years, right? 1 over 6 years. And the half-life is 88 years. So 1 over 6 years, is that really a considerable amount when compared to 88 years? No, not really, right? So we can say the activity halves in 88 years, and the change of the activity in 2 months will be insignificantly small. Okay, 30. Xenon has several stable and unstable isotopes. One stable is 54 protons, 75 neutrons. Complete the diagram. Okay, 54 down, then up will be 54 plus 75, so it will be 129. Complete the diagram to describe the isotope whose atomic mass is 1 greater than the stable isotope's mass, so it will be 54, 128. Sorry, I meant 130. Oh, not 128. Let me make sure. Is this correct? Yeah, if it's 1 greater, and 129 plus 1. The half-life of one of the unstable isotopes is 8 days. At a particular instant, it's 640 BQ. Calculate the time taken to fall to 20 BQ. Remember, final activity, initial, over 2 to the power of n. The final activity 20, 640 over 2 to the n. You're going to get 2 to the n equals 640 over 20. 2 to the n equals 32. N equals 5. 5. So since it's 8 days for each half-life, it's going to be 5 times 8, so 40 days. Once the activity detected from the sample is 5 BQ, it no longer changes significantly. Explain. Because after 5, so to explain it, once it gets really low, okay, خلاص, it doesn't really matter anymore. Okay, all the sample has decayed, and now it's just due to background radiation. Okay, that's it. This isotope has medical applications. Name 2 medical applications of any unstable isotope. It would be to kill cancer cells, maybe to trace and sterilization purposes, sterilize any sanitization. Okay. Question 31. Question 31. A radioactive sample undergoes the following decay. So basically it's going through this decay. Okay, this cobalt becomes nickel and it releases an electron and a gamma. Gamma is 0, 0. Electron is negative 1, 0. فcan we find y? 27 minus 1, 28. Then 60 minus 0, 60. X is 60, y is 28. What type of decay does it undergo? You can't really say it's a gamma decay, okay? So we're gonna just call it a beta decay. That's how it is. You don't say it's a gamma decay. Okay, the sample is placed in an area designed by a magnetic field, okay, perpendicular to the plane of the page. Detectors are placed at points A, B, and C. This is out, because you're seeing the tip of the screw, okay? So it's coming towards me, okay? State which detectors will detect an activity due to the sample. Remember, we have beta, and it's going out. So where will it be? It's gonna be in A. It's gonna go up, right? So up, so it's gonna be A. How do we explain it? We always said negative, why is my phone tweaking? Negative particles will move counterclockwise when the magnetic field is outside the plane of picture. Is that correct? Because gamma ray, okay, what? Ah, why is it at A? Yeah, because we said it's better, and also at B. At B, we forgot about gamma, right? We forgot about the gamma radiation, so it's also going to be in B. So A due to beta and B due to gamma. Okay. All 3 detectors will continue to detect radiation even after the sample is removed, obviously because of background radiation is always present. Okay, consider a neutral atom of francium. Okay, state its protons, 87, electrons, also 87. Neutrons, 221 minus 87 would be 220 minus 86, 220, 22 minus 86, 14, 140, 134. Okay, nucleon, nucleons would be 2, 2, 1. Nucleons is protons and neutrons. Francium 221 decays alpha decay, forming astatine according to the following reaction. Okay, if it's alpha decay, and it's helium 2, 4. Okay, how do we find this? We do 87 minus 2, 85. 221 minus 4, 217. So we finished the okay, we completed. List 2 properties of gamma radiation emitted as francium. What are the 2 properties of gamma? So there are many characteristics of gamma. You can take any 2. Most penetrating power. It's an electromagnetic wave. It doesn't have a charge. It moves at the speed of light, and it has low ionizing power. C. The half-life of francium is 4.8 minutes. If the initial activity is 800, how much time must pass until it's 100 whatever. Okay, again, final activity equals initial over 2 to the power of n. Initial is 800, final is 100. So 800 over 100 equals 2 to the power of n. So 2 to the power of n equals 8. So n equals 3 half-lives, right? If each half-life is 4.8 minutes, 3 times 4.8, same story, we're repeating ourselves, 14.4 minutes. 14.4, yeah. Question 33. A human thyroid gland can absorb and store iodine. To test whether the thyroid gland acts normally, a person is asked to ingest a pill that contains a radioactive isotope of iodine. 2 hours later, the radiation level is measured in the vicinity of a person's neck where the thyroid is located. State and explain the type of radiation that must be emitted by the isotope used in this tracing procedure. Should be gamma. Why beta? So here it's beta. Okay? So look, here if you put alpha, alpha is going to get absorbed because low penetrating power. If you put gamma, none of the gamma will be absorbed. But if you put beta, some of it will be absorbed and some of it we can actually test. So that's why we're going to want beta. Okay, for these types of experiments, it's always good to use beta. Below are several iodine isotopes and their half-life. Okay, which of these isotopes is most suitable for the thyroid function evaluation? Explain your answer. Obviously, we're not going to use 111 because the half-life is 2.5 seconds. We're not going to have time for anything. If we use 123, it's 13 hours. That's good enough. Obviously 125 and 129, it's too long. 59 days and 1.57 million years is too long. So 13 hours is in the middle, so that's good. The iodine 131 isotope has a half-life of 8 days. If its initial activity, okay, this is the same, but we're repeating ourselves, خلاص. Okay, so initial activity, final activity. They want final activity. Final activity is initial activity divided by 2 to the power of n. Okay, initial activity is 250 divided by 2 to the power of n equals final activity. Okay, do we know how many half-lives? Each half-life is 8 days, right? So one half-life, 8 days, to x half-life, 12 days. If you cross multiply, you're gonna get 12 divided by 8. You're gonna get half-life equals 1.5. So that means n equals 1.5. So you're gonna do 250, that's 250 over 2 to the power of 1.5. Is that correct? 88, yeah. Chapter 8. Okay, define energy. Energy is the ability to cause a change, right? And it can take its forms in different bodies. What is the principle of conservation of energy? Energy cannot be created nor destroyed. Oh, okay, it's the same thing. Okay, in an isolated physical system, there exists energy which remains constant. In any isolated system, the energy remains constant. Okay. Explain how energy in bottled gas helps you make a hot cup of coffee. Discuss in class. Okay, yeah, that's not coming. How can the energy supplied to a tree by the sun help pull a train? So this is a grid, so it could come. Okay, how can an energy supplied to a tree help the sun? By the sun help pull a train. The tree captures the light energy and changes into chemical energy by photosynthesis. Okay, everybody should know this. So it causes and grows, it stores, it could cause a tree to grow and store energy in its leaves as chemical energy. Later, you can burn this tree and release it as thermal energy, right? Okay, this thermal energy can turn water into steam, and the steam engines in trains. You burn stuff and it releases heat that causes the train to move, causes kinetic energy. Describe the 3 forms of energy. The 3 forms of energy are here: internal energy, heat energy, and chemical energy. Internal energy is the random thermal energy, the intermolecular and chemical potential. So they ask this always: internal energy, random thermal energy, intermolecular and chemical potential. Then we have heat energy. Heat energy is the hotness of the body. Okay, and then chemical energy is the energy stored in chemical and in food, also fossil fuels. Explain the transfers of energy involved in making a car run using fossil fuels. Start with solar energy. Solar energy. Oh, okay. Yeah. So Okay. So solar energy is absorbed by living organisms and stored as chemical energy. The plants, they absorb the light energy, the solar energy, change it into chemical energy using photosynthesis. When they die and decompose, they turn into fossil fuels that when we burn them, releases energy in cars as mechanical and thermal energy. Okay. Satan, explain Einstein's mass energy equation. It's, everybody knows it's E equals mc squared. Okay, so, okay, yeah, you just need to know E equals mc squared. That's it. What does internal energy refer to? Internal energy refers to the internal energy. You have to memorize this. It refers to the random thermal, the intermolecular potential, and the chemical potential. Okay. Uh, define heat energy. Heat is the hotness of the body, and there's three things that make it up: the random thermal energy, the radiant energy, and the internal energy. Make sure you memorize this. Okay. Random thermal energy, radiant energy, and internal energy. Then question 9, they asked, what is chemical energy? Chemical energy is the form of potential energy that's found in fossil fuels and food. Okay, those are the main two. What is radiant energy? Radiant energy is the light energy, right? It's electromagnetic radiation. It's a form that can travel in vacuum, such as light. Okay, and then he said, what's a photocell? Photocell converts, It's with light falling on the metallic surface knocks electrons out of the surface. Electrons knocked out of their places drift across to another term, generating electric current. Okay, well, what a photocell is, it converts light energy to electric energy. But I think here they're explaining how it does it. You're not required to know that, but know that converts light energy to electric energy. Arrange the components of electromagnetic spectrum in increasing frequency. So, in increasing frequency, you start with the lowest. Starts with radio waves, microwaves, infrared, visible, ultraviolet, X-ray, gamma. Memorize this, please. What can be said about the speed of all electromagnetic waves in vacuum? They all run at the speed of light. Okay, it's travel the same speed, and it's actually the speed of light. Determine the type of electromagnetic used in each appliance. Television, أكيد radio waves. Tanning bed, ultraviolet. Medical imaging of bones, أكيد X-ray. Closed container image, what's closed container? Gamma, I think. Yeah, gamma. Because everything goes through, the gamma goes through everything. In a stretch bow, where is the elastic potential energy stored? In the bow, the arrow, or in both? And then they say only the bow changes its shape. So obviously, only the bow. The only thing that's being distorted, the only thing that's having its shape being distorted, is what has the elastic potential energy. When coal is burned to generate electricity, the efficiency of the system is about 40%. That means, 60% of the energy is lost, only 40% is actually used. Okay? A windmill uses wind energy to operate a current generator, which lights a light bulb. Which of the following forms of energy is not involved in the process? Kinetic, heat, electrical, chemical potential, gravitational potential. Obviously, chemical potential and gravitational potential chemical potential and gravitational potential won't be used إنه شو خاصهم بالwind and light. Wind obviously would use kinetic energy to move the windmill, okay, and obviously electrical energy to light up the light bulb. Heat energy will be used because when you light a light bulb, this is the light bulb, okay, you have this small line, it becomes red when you light a light bulb, that is the resistor, so there will be heat energy being used, okay. So the only thing not being used is chemical potential and gravitational potential, okay. 17, they say state the energy transformations occur in a battery. Okay, make sure to memorize the table below. In a battery, it goes from chemical to electric. Candle, it goes from radiant to, I think, radiant. Sorry, I mean chemical, it burns the chemical candle, so chemical to radiant. Electric motor is electric to mechanical. Solar panel is radiant to electric. Yeah. Question 18, describe the energy transformations here. Wind turbine is mechanical or kinetic energy or mechanical energy to electric. Nuclear is nuclear to electric. Solar is radiant to electric. Yeah. Give 2 reasons for saving fossil fuels. Why? Because it's obviously it's ethical. Okay, I'm just gonna give you the answer key. Okay, we should save it. One should save the limited resources for uses other than burning. Okay, one should save the environment because to stop pollution, right? So obviously we should use it other than burning. Second thing, to stop pollution. Okay, guys, you shouldn't. Okay, it's very bad. We're hurting our environment. Okay, then for the third one, it's a shame. Okay, guys, it's actually a shame. Okay, it's not. You guys are doing your planet dirty. You can't be doing this. Okay, it's a shame to simply burn up the remaining quantities of these valuable materials. Instead, we as humans should find alternative sources of energy. Give one consequence of global warming. Obviously, the absorbed heat could drive up the planet's temperature. Obviously, the waters rise, um, icebergs will melt, and flooding. Okay, just memorize the points, don't memorize the whole paragraph. Okay, define the greenhouse effect and identify two main gases responsible for it. Greenhouse effect is the trapping of radiation on our planet, and two main gases are carbon dioxide and water vapor. Okay, so the heat trapping effect is mainly to water vapor and carbon dioxide. Give two ways to reduce fossil fuel consumption. Okay, you can use natural gas, using solar energy, improving insulation of buildings, using hybrid cars, and using air conditioning. They meant using air conditioning by solar panels because air conditioning just like that doesn't make sense. What are some methods that can be used to reduce consumption of fossil fuel? Okay, increasing the use of hybrid cars, using natural gas. We're just repeating ourselves. Nuclear energy. What type of nuclear reaction is used in a nuclear power plant? Obviously, in a nuclear power plant, we don't use fusion, we use fission. Okay, because fission gives you way more energy than fusion. It's just inefficient. Give two disadvantages of nuclear power plants. Obviously, they're expensive and there's bias. Uh, it's high price. There's radioactive waste. Waste is the most important one. If you ask me what's the most important one, it's radioactive waste. Define the term renewable energy. Energy that can be renewed, yani. Energy that will not run out. Okay. Describe how hydroelectric energy is obtained and how it generates energy. Okay. Hydroelectric energy is the one that we use with gravitational potential energy. Okay, it's used by converting the gravitational potential energy of water stored in dams into kinetic energy used to rotate turbines. So you'd have water up here, okay, very high. It's gonna have gravitational potential energy due to mgh because it's raised to a height. It's gonna fall and it's gonna increase its kinetic energy at a very high speed. It's gonna move these turbines that are gonna generate me electricity. Okay. Question 28. List four sources of renewable energy. Solar, wind, hydroelectric, okay, wind, hydroelectric, tidal, waves, ocean thermal, geothermal, solar energy, biomass, hydrogen gas. Okay. Different methods of generating electricity exist. These methods have advantages and disadvantages. Determine the disadvantage of each of the following. Wind power, too expensive. Hydroelectric, it's no, actually, you know what? Wind power, sorry, it's seasonal. Okay, it depends on the weather. Okay, hydroelectric, the energy produced is very far away from where it's being used. Tidal energy, uh, it's expensive, I guess. Yeah. And then geothermal, I don't know. Let me see this. The use of wind power on a large scale raises issues of visual impact, noise, and effect on local wildlife. If you said it depends on the weather, that also is fine. Disadvantage of hydroelectric power is that they are a long way from where the electricity is needed. Constructing water dams involves burying large areas underwater, situations that cause real environmental ecological threats. Tidal stations are expensive. Okay. The disadvantage of geothermal energy is that it acts as a source of electric power. It's very inefficient. Geothermal is very inefficient. Okay, if you want the table here, okay, you have take a screenshot of this, okay, and then this one over here, okay, just saying, they're good, nice to have it. Question 30. Describe how energy can be generated from microbes. Okay, they basically want to make genetic engineers want to design microbes that use sunlight energy to turn carbon dioxide into natural gas or produce hydrogen gas. Okay, so they want to make bacteria or microorganisms that they capture sunlight energy to turn carbon dioxide, the harmful gas, into natural gas. Chapter 9. Consider a system consisting of three bodies A, B, and C that can only interact with each other. Through these interactions, energy is transferred from one body. What is the net energy gained or lost by the system A, B, and C? Zero. Should be zero? Yeah, zero. Because it's an isolated system. Always the delta E in any isolated system is zero. When does energy transfer occur? When does it occur? When a force is being applied over a certain distance. Work. Yeah, so like I was saying, work equals force times distance. For energy transfer occurs when there's a force over a certain distance. Question 3. Find the amount of energy transferred from you to each of the following. A mass 100 gram lifted through 1 meter. Okay, so you have to it's force times distance, and the force is mass times g. So the mass 0.1 kilograms times g, which is 10, so 1. So 1 times 1, 1 joule. It's energy, so it's a joule. Mass of 1 kg through 10 centimeters. 10 centimeters, 0.1 meters. So 1 times 0.1, 0.1 joules. No, sorry. It's force times distance. So force is mass times mg. So 1 times 10 is 10 newtons times 0.1. So it's 1 joule. Again, 1 gram through 10 meters. 1 gram is, it's going to come 0.01 newtons. Because you do mg. Make it kilograms and multiply by 10. You get 0.01. And then 10 meters, 0.01 times 10, 0.1 joules. Your own body, if you go up a distance of 1 meter, they think your own body if you go up a distance of 1 meter. So the mass of your body if you go up a distance of 1 meter. They put 700 newtons as my weight. Way more than that. 700 newtons is too little. بس يعني okay, obviously they won't bring something like this. Question 4. What is the SI unit of work? It's joules. Define it. It's the energy needed to push 1 newton to a distance of 1 meters. Right? It's the amount of energy when a force of 1 newton is acting on 1 meter. Calculate the work done. 40 newtons. Distance of 12. 40 times 12. 480. What is the work done by a tractor of magnitude 2000 over 50 meters? Okay, force times distance 2000 times 50, 100,000 joules. Make sure you put the unit. Differentiate between motive and resistive work. Okay, motive work is when the force and distance are moved in the same direction, so you're pushing it in the same direction. Resistive, it's resisting the motion, so the force and distance are in opposite directions. State and derive the work energy theorem. Okay, the work energy theorem states that work is equal to the change in the kinetic energy. So work equals delta Ke. So the work, or the sum of all the works, but in this case usually it's one work, equals kinetic energy final minus kinetic energy initial. Final kinetic energy is half mv final squared. Initial kinetic energy is half mv initial squared. Okay, and work is force times distance. We forgot to update our formulas. Chapter 7 was final mass equals initial mass over 2 to the power of n. Chapter 9 now, work is force times distance. It's the same for activity, huh? So activity final equals activity initial over 2 to the n. Work is force times distance. Kinetic energy half mv squared. So this is the work energy theorem. Okay, so do I write it for you? I'll write it for you. Delta no. Work is equal half mv final squared minus half mv initial squared. So you're just proving it. There's no need to know the proof عادي. A 1 kilogram body resting on a horizontal frictionless surface is pushed with a net force F 4 newtons to a distance of 2 meters. Calculate the final kinetic energy of the body. So when you're talking about mass, force, distance, that means we're relating the work to the kinetic energy. We said work is equal to delta Ke, or Ke final minus Ke initial. So work is force times distance. So 4 times 2 equals final minus initial. Let's just say Kef minus Ke I. Initial kinetic energy is 0 because it was at rest. Okay, so kinetic energy final is going to be equal to 4 times 2. So do we just find the final kinetic? It's 8 joules. Okay, 1 kilogram body moving with velocity of 3 is pushed a distance of 2 meters in the same direction as its velocity on a horizontal frictional surface with a net force of 4 newtons. Calculate its final kinetic energy. Same formula. Work equals final minus initial. Work is force times distance. So 4 times 2, 8 equals final kinetic energy, which is half mv final squared. Or they don't want velocity, they just want the final kinetic energy. So let's keep it as final kinetic energy. They gave us the initial velocity and they give us the mass. So can I find the initial kinetic energy? Yes, I can. Half mv initial squared, صح? So let's take this down. 4 times 2, 8 equals final kinetic energy minus half mass, which is 1. V initial squared is 3 squared. So you're going to get minus 9 over 2 if you multiply these. So kinetic energy final minus 9 over 2 equals 8. Take 9 over 2 to the other side, you're going to get kinetic energy final is 12.5 joules. Part C, the above 1 kg body, now moving with a velocity of 5 meters per second, is pushed in the opposite direction to its velocity with a net force 8, distance of 1. Now, they don't want final kinetic energy, they want final velocity. So you have to use the full formula. Work, force times distance, work equals delta K. So force times distance equals half mv final squared minus half mv initial squared. Force times distance, 8 times 1 equals half times 1 times v final squared, we don't know, right? So we're going to keep it vf squared minus half times 1 times initial squared will be 5 squared. Let's substitute. 8 equals v final squared over 2 minus 25 over 2. Okay, multiply everything by 2. You're going to get 16 equals v final squared minus 50. So minus 50 because I multiplied. No, minus 25. I'm going to get v final squared equals 41. So v final equals root 41, which is a decimal, I think. What? Oh, wait. They said it's moving, it's pushed in the opposite direction. So the work is negative, okay? It's negative 8, okay? negative 16, it becomes 9. After you add 25 on the other side, it becomes 9. So radical 9, so you get V final is 3 meters per second. A small block of mass 4 kg is moving on a level plane against a constant resistance 25 newtons. If the initial speed is 15, find its final speed after moving 10 meters. So first thing, okay, again, since we want final velocity, you have to use, again, force times distance equals half mv final squared minus half mv initial squared. Okay, force times distance will be negative 25 times 10. Why? Because it's a resistance force. Resistance, yani it's negative, it's in the opposite direction. Equals half mv mass is 4. So why did I put this? The mass is 4. Half times 4 times the velocity. We don't know what vf squared is, right? Minus half m is again 4 times v initial squared, 15 squared. Let's clean it up. Minus 250. Half times 4 is 2 vf squared. And then half times 4, 2 times 15 squared will be 450. So you're going to get 2 vf squared. If you add on the other side equals 200, you divide by 2 now, you're going to get vf squared equals 100. Vf equals root 100 equals 10 meter per second. I think they're going to get something like this in the written somehow. Okay, a ball of mass 200 grams, let's put it in kilograms, okay, 0.2 kilograms, is shot upwards with velocity of 5. The ball reaches a maximum height before it falls back. Find the initial kinetic energy of the ball. We know kinetic energy is half mv squared, so direct application, half times the mass, 0.2, times the velocity, 5 squared. You're gonna get 2.5 joules. Yeah, don't forget the unit, huh? 2.5 joules. What is the kinetic energy of the ball at maximum height. Once it's at maximum height, velocity equals 0. So then kinetic energy will be equal to 0. Is it correct? Yeah. Part C. If h represents the maximum height the ball can reach, measured from the level essentially sought, express the work done by gravity in terms of h. Listen to this note. The work done by gravity is pushing it down, right? But the ball is going up. So isn't the work done by gravity negative? Yes. Okay. And the work done by gravity, when you're talking about height and stuff, it's always mgh. Since it's negative, because it's going the opposite direction, it's negative mgh. So here, negative mgh is going to be equal to w. Okay, our mass is 0.2, so negative 0.2 times g. If it's not given, it's 10 times height. They said keep it in terms of h. Negative 0.2 times 10 times height is negative 2 height. Is that the answer? Yes. Part D, using the work energy theorem, determine the value of h. What is the work energy theorem? It's work equals delta Ke, or Ke final minus Ke initial. Don't we have everything given already? Initial, we said it's 2.5, right? Final, we said it's 0. So 0 minus 2.5 equals the work, which is minus 2h. Can't we just solve it? Yes, we can. Okay, we can divide by negative 2 on both sides. We're gonna get 1.25, I think, meters. Is this correct? 1.25 meters, yes. Question 11. A ball of mass 200 grams is shot vertically from the ground upwards with a certain velocity. The ball reaches a maximum height of 7 meters. Determine the work done by gravity from the moment the ball is done until it reaches its highest point. Okay, work done by gravity is equal negative mgh. Why? Because it's going upwards, but the gravity is pushing it downwards, so the opposite direction, so negative. Okay, so in this case, it's going to be negative the mass 0.2 kilogram times g, which is 10, times the height 7. So you're going to get negative 14 joules. Make sure you put the unit joules. Okay, joules. 9.5, 4 boxes initially at the same level will reach different heights. Okay, okay, box A, 3 kg, this is 0.5, 2 kg, 1. Okay, which of the boxes increases potential energy to the greatest amount? So let's calculate each one. mgh, right? Potential energy. mgh. So mgh. So 3 times 0.5, 3 times 10 times 0.5 equals 15 joules. 2 times 10 times 1 equals 20 joules. 1 times 10 times 1.5 equals 15 joules. 0.5 times 10 times 2 equals 10 joules. Which one has the highest? Obviously, box B. If the boxes are not allowed to fall back to the ground, which one will be traveling the fastest when it reaches the ground? Obviously, the one that has the highest potential energy will have the highest kinetic energy. That means it will have the that means it will have the highest velocity. So I think it will be box B. Oh no, box D. Sorry. I forgot something. Okay, but box B obviously is for part A. A new formula is V equals radical 2gh. Okay, so as height increases, the value of V increases. Okay, so over here, the one that's lifted to the highest height will have the highest velocity. Okay, so V squared equals 2gh, which is independent of the mass. A window cleaner of mass 75 climbs up to a third floor window 8 meters. What is its potential energy? Obviously, mgh. So it's going to be 75 times 9.8 times 8. يعني ما فيش أسهل من هيك. Just multiply. You need to put it in joules. Don't forget. Question 14. The seat of a swing is 30 centimeters above the ground when it is stationary. When swinging, a boy passes through the lowest point with a speed of 6.5 meters per second. What is the height of the seat when it comes to rest? So for this question, it's important to understand. I'm going to try drawing it for you. The seat of the swing is 30 centimeters above the ground when stationary. So when it's stationary, the swing, let's call this the swing. Okay, you have this here. Okay, this is 30 centimeters. We're taking the seat of the swing as the reference point. Okay, this is the reference point. When working with potential energy and kinetic energy, that means we're working with mechanical energy. Always note that the mechanical energy before is equal to the mechanical energy after. The mechanical energy is expressed as the sum of potential plus kinetic. So PE1 plus kinetic energy 1 equals PE2 plus kinetic energy 2. We have two instances, when it is stationary and when it is swinging. When it is stationary, that means V equals 0. So do I have kinetic energy? No, right? Okay, then when swinging, he passes through the lowest point. So the lowest point with reference to the swing. So my potential energy, will there be potential energy when I'm at the lowest point? No, so I won't have a PE2. Will I have kinetic energy 2? Yes, because I have a speed of 6.5. So now I can just plug in the values. Potential energy 1 is mgh. Kinetic energy 2 is half mv squared. Mass cancels with the mass. So I'm going to get gh, so 10 h, because g is 10, equals half times 6.5 squared. And if you solve for h, you get 2.115 meters. Okay, so then they're saying what is the height of this heat when it first comes to rest? Okay, so it's 30 centimeters above the ground, and then it's 2.115 up. So like when it's swinging over here, 30 centimeters above and 2.115 meters. Convert this to meters, you're going to get 210 centimeters. So if you add this 210 and this 30, you're going to get that the total height is 240 centimeters above the ground. Question 15. A sled initially at rest is pushed to the right with a force of 10 newtons for 2 meters on a frictionless surface. Draw the force diagram of the sled. Okay, it's pushed, obviously have the weight and the normal, and then it's pushed to the right, the force. Okay, is mechanical energy conserved? Why? No, it's not conserved. Mechanical energy, okay, remember this, mechanical energy is only conserved when the only force acting on the object is the weight. But here we have an external push. Okay, so it's not conserved since there's an external force. Okay, remember that. When do you have mechanical energy conserved? When the only force is the weight. Okay, external force, yani no more mechanical energy. Using the work energy theorem, calculate the final kinetic energy of the sled. Work energy theorem, force times distance equals kinetic energy final minus kinetic energy initial, right? Okay, our initial kinetic energy is 0 because it's at rest, right? So V equals 0. So my final kinetic energy would just be equal to force times distance. So 10 times 2 equals 20 joules. So we found our final kinetic energy. Find the speed of the sled if its mass is 5 kilograms. For this one here, we know that the final kinetic energy is 20. So kinetic energy final is 20 joules. They're saying if the mass is 5, what's the velocity? We know kinetic energy is half mv squared. And we know that this is equal to 20. If we just plug in the mass is 5, can we find the velocity? Of course we can. Okay, so you're going to get 5 over 2, v squared equals 20. So v squared will just be 40. So no, v squared would be 8. If you multiply by 2 over 5 on the other side, you get 8. So v will be equal to root 8 meters per second, which is 2.83 meters per second from the calculator. Okay, said verify your answer using the laws of dynamics and kinematics. How do you do that? If you want to verify your answer using the laws of kinematics, in case this comes, okay, I don't know if it will come. The first thing you're going to want to find is your acceleration. You know, force equals mass times acceleration. Force is 10, mass is 5, so 5a, obviously a equals 2 meters per second. The second step is to plug it into v squared minus u squared equals 2ax. V squared, we don't know it. U squared is 0 because we started at 0. 2 times how much was the distance traveled? 2, right? 2 meters. 2 times 2 times 2, so v squared equals 8. That means v equals radical 8. Means v equals 2.83 meters per second. You get the same answer. 16. Yeah, for question 16, a 60 kg swimmer jumps into a pool and that's 6 meters above the pool. Okay, so height is 6, okay, mass is 60. Okay, assume the initial speed is 2 meters per second and the pool level is taken as a reference for the gravitational potential energy. What is the initial mechanical energy of the swimmer? Mechanical energy is always equal to kinetic energy plus potential energy. Okay, kinetic energy, so half mv squared plus mgh. So in this case, it will be half the mass is 60 times the velocity squared, so 2 squared, plus the mass 60 times g, which is 10, times the height 6. And you get, if I'm not wrong, 3720 joules. Always remember joules. Then for our last question of today, a small block, mass m is dropped from a height of 0.8 meters. Find its speed when it's 0.6 meters above the ground. Neglect friction forces and use g equals 10. Look here, when you have something like this, again, we're working with potential energy, kinetic energy, use mechanical energy 1 equals mechanical energy 2. So that means kinetic energy 1 plus potential energy 1 equals kinetic energy 2 plus potential energy 2. Remember, for these conditions to work, weight must be the only force. And remember here, it's only weight, just the weight of the block pushing it down. Kinetic energy 1, when it's being dropped from height 0.8, it's still not moving. So kinetic energy 1 is 0. Potential energy 1 would be mgh1 equals kinetic energy 2. Kinetic energy 2 is going to be half mv squared plus potential energy 2 would be mgh2. Let's see, mgh1, the mass is m times g 10 times the height 0.8 equals half m again times velocity squared, we don't know it, right? Plus mgh2 m again times g times the second height 0.6. Let's clean it up. M times 10 times 0.8 is 8m equals half m v squared plus 6m. Take 6m to the other side, you get 2m equals half mv squared, m with m, 2 equals half v squared, multiply by 2 on the other side, v squared equals 4, v equals 2 meters per second. 12:15 in the morning. I've been recording since 4 p.m. 4 hours and 12 minutes. Good luck in your physics final.